In 2025, something extraordinary happened. 7 comets, each with its own unique origin and trajectory, appeared within the span of just 1 year, many of them arriving in close proximity to Earth and Mars. For astronomers and space enthusiasts alike, the timing and nature of this event was both fascinating and perplexing. How could such a seemingly rare cosmic occurrence happen all at once? Was it just an incredible coincidence, or was there something more to this unusual surge of celestial visitors? While comets are not a new phenomenon, the sheer volume and proximity of these 7 comets raised eyebrows. After all, the solar system is vast, and while comets have been spotted before, the simultaneous arrival of multiple comets in the same year was extraordinary. These objects, traveling from the outer reaches of the solar system or even from distant interstellar space, had been on their journeys for millions of years. Yet, against all odds, they all converged on our cosmic neighborhood in 2025, just as if they were being pulled by some unseen force or cosmic event. For scientists, the question was clear. Was this a rare coincidence in the randomness of the cosmos, or was there a hidden connection between these objects? Could there be a larger, unknown phenomenon at work? And what did their sudden convergence mean for our understanding of the solar system, the galaxy, and the forces that govern their motion? As we delve into this mystery, we will explore the peculiarities of these 7 comets and investigate whether they might share common origins or if their arrival can be explained by some other cosmic factor. Buckle up for a journey into the unknown as we explore the secrets of the cosmic traffic surge and try to answer the biggest question. Is it just a coincidence, or is something far more profound at play? The 7 comets that arrived in 2025 each had their own unique story, but together they formed a cosmic puzzle that scientists could not ignore. To fully appreciate the significance of this event, let's take a closer look at these comets and the roles they played in this cosmic surge. One of the most notable comets to appear in 2025 was C/2025 R2. Discovered early in the year, this comet quickly gained attention due to its unusually bright tail and rapid movement toward the inner solar system. By the time it was visible to the naked eye, astronomers had already begun to notice its highly elliptical orbit. C/2025 R2's path brought it incredibly close to the Earth, though it would not collide with the planet. As its tail stretched across the sky, many observers noted how stunningly bright and striking it appeared, a celestial phenomenon not seen in years. However, what was even more interesting than the comet's appearance was its chemical composition. Unlike many other comets, which primarily release water vapor and carbon monoxide, C/2025 R2 exhibited an unusual combination of carbon dioxide, carbon monoxide, and even methane. This cocktail of chemicals raised an intriguing question. Could the composition of this comet be linked to something larger, something related to the other comets that had appeared during this same period? Was there a common origin to these objects? Or were they all exhibiting unique traits due to the forces they encountered in their journey through space? Another comet that played a major role in this surge was Pan-STARRS, one of the more well-known comets in the group. Discovered by the Pan-STARRS survey in 2025, this comet was already on the radar of astronomers due to its unusual trajectory. What stood out about Pan-STARRS was not just its size and trajectory, but its close pass near Mars. Unlike other comets which tend to pass near Earth, Pan-STARRS's proximity to Mars made it an object of study for both Earth-based and Martian-based telescopes. Its tail also grew rapidly as it approached the Sun, and it became visible to the naked eye by the middle of the year. Interestingly, Pan-STARRS exhibited some peculiar features that distinguished it from other comets observed in the same year. Notably, its orbit was highly tilted compared to most solar system comets, which follow orbits that are relatively close to the plane of the solar system. Pan-STARRS's orbit, however, was significantly inclined, suggesting that its trajectory might have been altered or influenced by factors outside the normal solar system mechanics. Could Pan-STARRS be part of the same cosmic event that was sending other comets our way? Or was it simply a coincidence? The third comet in the group, Atlas K1, quickly gained notoriety due to its striking appearance and the scientific data it offered. Atlas K1 was unique not just because of its close passage by the Earth, but also because it was one of the brightest comets to be seen in years. Astronomers and enthusiasts alike were captivated by its spectacular tail, which seemed to stretch across a large part of the night sky. What made Atlas K1 particularly intriguing, however, was its chemistry. Unlike many comets, which are made of primarily water and dust, Atlas K1 had been found to have traces of cyanogen, an extremely toxic compound composed of carbon and nitrogen. This unusual chemical makeup suggested that the comet had come from a star system with environmental conditions vastly different from those in the solar system. Could Atlas K1, with its strange chemical composition, be part of a larger group of objects influenced by the same forces that brought the other comets? In addition to the more well-known C-2025 R2, Pan-STARRS, and Atlas K1, 4 other comets entered the scene in 2025. Each had its own path and characteristics, contributing to the larger mystery. These included comets like Swan, Lovejoy, Neowise, and others, each with its own unique behavior, orbit, and composition. For example, Comet Swan, which had been detected earlier but became visible in 2025, displayed a stunning tail and was visible across large parts of the sky. Similarly, Lovejoy, which had a famously long orbital period, showed a bright, extended tail and attracted significant attention from amateur astronomers. These comets, while not as widely known as the first 3, nonetheless contributed to the puzzle, each bringing its own quirks and features to the cosmic event. As scientists studied these comets, it became clear that some were exhibiting similar traits, especially when it came to their trajectories. Many of these comets were on paths that seemed to defy the typical patterns expected of objects in our solar system. Were they simply a fluke, or were these comets being influenced by something larger? After cataloging the 7 comets, astronomers and scientists began to theorize about why these objects arrived in such quick succession. The sheer number of comets arriving within the same year sparked debates in the astronomical community. Was this all a coincidence, or could there be a deeper cosmic cause behind their clustering? The simplest explanation was that the appearance of these 7 comets in 2025 was simply a rare but naturally occurring event. Given that comets are often detected based on their orbits, it is possible that these objects had been on their respective paths for millions of years, and their convergence was merely a statistical anomaly. Scientists have long understood that the orbits of comets are unpredictable, and a clustering event like this could have been nothing more than an odd but inevitable occurrence. Astronomers who favor this theory point out that while the timing may seem suspicious, the sheer number of comets in the solar system and the vastness of space make it plausible that these comets could have arrived at roughly the same time, without any external influence. Another theory that gained traction was the possibility that these 7 comets shared a common origin, or were the result of a single cosmic event. Some scientists speculated that the comets might have come from a distant star system, perhaps part of a larger cosmic cluster, and their trajectories had been altered over time by gravitational forces or the effects of the sun's radiation. This theory would suggest that the solar system's gravitational field had somehow captured these comets at roughly the same time, either by drawing them in or nudging them into new orbits. The gravitational influence of the Sun, the planets, or even other interstellar objects might have been responsible for aligning these comets' paths. Such an event would have been rare, but not impossible. One of the most interesting and compelling theories involves 3I Atlas, the interstellar object that passed through the solar system around the same time as the comets. Could the arrival of 3I Atlas have somehow influenced the other comets' trajectories? It's possible that the immense gravitational forces of this object, or its electromagnetic fields, could have altered the orbits of nearby objects. As an interstellar visitor, 3I Atlas would have been traveling at an incredibly high speed, and its gravitational impact on nearby comets might have been enough to bring them into the solar system at the same time. While this theory remains speculative, it adds an intriguing layer of complexity to the mystery. Could 3I Atlas's passage be the trigger that caused these comets to converge on Earth? Or was it simply a coincidence that these interstellar and solar system objects were passing through at the same time? As scientists continued to explore the possibility that these comets were part of a larger pattern, they turned their attention to the ways in which comets interact with the solar system's gravitational fields. Most comets come from the Oort cloud or Kuiper belt, regions where comets are born and spend most of their lives. These areas are far from the Sun's influence, but when comets get too close, their paths can be altered by the gravitational pull of the Sun, the planets, or other celestial bodies. Some of the 7 comets may have been nudged into the solar system by the gravitational influence of Jupiter, or even Neptune. Other, more distant forces, like the presence of interstellar objects such as 3I Atlas, could have played a role in altering their orbits. As we draw the first part of our journey to a close, we are left with the lingering question: were these 7 comets simply a rare occurrence, or is there more at play in the cosmos than we can currently understand? The mystery remains, but the investigation is just beginning. What we do know for certain is that the study of these comets, whether they share a common origin or were influenced by external forces, holds great potential for our understanding of the solar system and the broader universe. As the astronomical community observed the unusual surge of 7 comets arriving near Earth and Mars in 2025, theories began to emerge about what might be causing this rare cosmic event. While the idea of a cosmic coincidence was one possibility, many scientists found it hard to dismiss the idea that there could be an underlying connection, whether gravitational or even electromagnetic. Could these comets have shared an origin, or was there a more complex, interrelated cosmic mechanism at play? The simplest explanation, and one that some astronomers lean toward, was that the simultaneous appearance of these 7 comets was simply a coincidence, a rare but naturally occurring event in the vast expanse of space. Historically, comets have appeared in irregular cycles, with some years seeing many comets and other years seeing few or none at all. Given the unpredictability of the cosmos, it is not impossible for a random alignment to occur, where 7 comets make their way into the solar system within the same year. On the surface, this theory seemed plausible. After all, there are millions of comets scattered throughout the solar system, many of which come from the distant regions of the Oort cloud or the Kuiper belt. The solar system is also constantly moving through space, encountering new regions of the galaxy and potentially interacting with unknown cosmic forces. It is not unreasonable to suggest that 7 comets could enter the solar system during the same period as a result of random cosmic chance. However, as astronomers began to analyze the data, they quickly realized that the pattern was far too significant to be dismissed as mere chance. The arrival of these 7 comets was not just an isolated incident, it seemed to be part of a larger, more intricate cosmic event. If these 7 comets were not just a random occurrence, what could be the cause of their simultaneous arrival? Could there be a connection between them, or even a shared origin? The possibility that these comets came from the same region of space, or that they were somehow influenced by the same cosmic event, was quickly explored by scientists. One compelling theory was that these comets might have originated from the same part of the galaxy, and their paths were altered over time by gravitational forces or other cosmic factors. In particular, the gravitational influence of the Sun, or even the interaction between comets, could have nudged them into similar trajectories, causing them to arrive at the same time. Some researchers also speculated that the comets might have been part of a larger swarm of objects that had been disturbed by a gravitational event, such as the passing of a nearby star or a shift in the galaxy's gravitational structure. The idea was that these objects, over millions of years, could have been part of a larger cosmic event that altered their orbits and caused them to converge on the solar system. Another possibility was that these comets were part of a cluster of objects from a single distant star system. If a nearby star had passed close enough to our solar system in the past, perhaps millions of years ago, it could have disturbed the orbits of objects in the Oort cloud or the Kuiper belt, sending a group of comets hurtling toward the inner solar system. This idea was appealing because it could explain not only the appearance of multiple comets in a short period of time, but also the shared characteristics of the comets. Perhaps the most fascinating theory to emerge was the idea that 3I Atlas, the interstellar object that had recently passed through the solar system, could be influencing the arrival of these comets. 3I Atlas, traveling at an incredibly high velocity, was not bound by the Sun's gravity and had come from outside our solar system. Could its arrival, with its immense speed and unique properties, have altered the trajectories of the nearby comets? While the gravitational influence of 3I Atlas would likely be minimal, its passage through the solar system could have triggered a chain reaction of gravitational or electromagnetic interactions with the comets. 3I Atlas's passage might have disturbed the Oort cloud or other distant regions of space, causing some comets to shift their orbits and head toward the inner solar system. This hypothesis would require further investigation, but it offered a tantalizing. The possibility that the interstellar object could have been a catalyst for the cluster of comets arriving at the same time. Another possible mechanism could involve electromagnetic interactions. Interstellar objects like 3I Atlas are capable of generating magnetic fields and cosmic radiation, which might influence the behavior of nearby objects, especially comets. While comets are generally influenced by gravitational forces, they also interact with electromagnetic forces, especially when they approach the Sun. If 3I Atlas were emitting powerful electromagnetic fields, it could have affected the behavior of nearby comets, causing them to shift or align with the solar system in ways that were not previously understood. The Sun plays a significant role in the behavior of comets, especially as they move through the inner solar system. As comets approach the Sun, they are subjected to the solar wind, a stream of charged particles emitted by the Sun. This solar wind interacts with the comet's tail, creating the bright, glowing trails that are characteristic of comets. The Sun's gravitational pull also influences the comets, altering their orbits and speeding them up as they approach. Some scientists proposed that the clustering of the 7 comets could be explained by a shared experience with the solar wind or gravitational pull. As these comets moved through the solar system, they could have been affected by the same forces, causing them to arrive at the same time or align in a specific region of space. The possibility that the Sun's activity could have influenced the paths of these comets was explored, though it remained one of the more speculative ideas. One particularly interesting hypothesis was that the comets could have been part of a larger cosmic cycle, with their arrival triggered by a specific alignment of the Sun's activity or the positioning of other celestial bodies in the solar system. Could the Sun have experienced an increased period of solar activity, such as a solar flare or coronal mass ejection, that affected the trajectories of these comets? While the timing of solar activity did not fully align with the appearance of the comets, the idea raised important questions about how solar phenomena might influence the movement of objects across the solar system. By this point in the investigation, astronomers were beginning to recognize that the sudden surge of 7 comets could not easily be explained by a single factor. Instead, the event seemed to be the result of a combination of forces, some known, some speculative, that had converged to create a rare cosmic alignment. Could these forces have a hidden connection, or were they simply an unlikely but natural series of events? Astronomers began to analyze the positions and orbits of the 7 comets in more detail, looking for any patterns that might suggest a common origin or external influence. Were these comets part of a larger cluster of objects, or were they drawn to the solar system through separate, independent processes? Could the arrival of 3I Atlas have been the key factor in triggering the appearance of these comets? As the analysis continued, it became clear that the more comets scientists studied, the more questions emerged. Despite the theoretical models and proposed explanations, the actual cause of this surge in cosmic traffic remained elusive. The arrival of 7 comets in one year had profound implications for our understanding of the solar system. It suggested that the solar system was not as isolated as previously thought, and that objects from distant regions of the galaxy and beyond could have a significant impact on its dynamics. While the comets themselves did not pose any immediate threat to Earth, their arrival highlighted the need for better tracking and detection systems. The unexpected clustering of these objects suggested that we may not be fully prepared for the next cosmic event, whether it is another cluster of comets or an even rarer interstellar object like 3I Atlas. This event also raised questions about the long-term stability of the solar system. Could the arrival of multiple interstellar objects over time change the structure of the solar system, or could it be a temporary phenomenon that has no lasting effect? The answer to these questions may require decades or even centuries of study, as astronomers continue to track these objects and measure their effects on the solar system. As the investigation into the 7 comets continues, astronomers are already looking ahead to the next possible cosmic event. Will we see another surge of comets in the near future? Will interstellar objects like 3I Atlas become more common as our detection systems improve? The future of cosmic traffic is uncertain, but the data gathered from this surge will undoubtedly shape the way we study and prepare for future encounters with objects from beyond our solar system. This cosmic mystery, while puzzling, has provided valuable insights into the forces that govern the solar system and the broader galaxy. The appearance of these 7 comets has shown us that the universe is full of surprises, and the more we learn, the more we realize how much we still have to discover. The arrival of 7 comets in 2025 is an event that will continue to captivate astronomers and the public alike for years to come. Whether or not these comets were part of a grand cosmic plan or simply the result of random chance, their arrival has opened up new avenues of exploration. The search for answers continues, and as we look to the future, we must be prepared to encounter even more cosmic surprises that could change our understanding of the universe. As the comets of 2025 streaked across the skies, their sudden appearance near Earth and Mars raised profound questions about the forces at play in the solar system. While many speculated about the influence of interstellar objects like 3I Atlas, it is equally important to understand the role our Sun might have played in this extraordinary event. The Sun, with its immense gravitational pull and powerful solar wind, exerts a profound influence on all objects within the solar system, including comets. The Sun's solar wind, a continuous flow of charged particles, mainly electrons and protons, emanates outward from the Sun's corona and extends far beyond the orbit of Pluto. This wind interacts with comets as they approach the Sun, and it plays a pivotal role in the formation of a comet's tail. As a comet nears the Sun, the solar wind pushes against the comet's ice and dust, causing sublimation, the process by which solid ice turns directly into gas, creating a coma and tail. While the 7 comets in question may have originated from different regions of the solar system, the role of the solar wind in shaping their tails and behavior cannot be overlooked. The solar wind may have been responsible for some of the visual aspects of the comets as they became visible to the naked eye. But the impact of the solar wind likely extends beyond just the visual phenomenon. Could the solar wind also play a role in influencing their trajectories? Could it have nudged some of these comets onto paths that led them to intersect with Earth's orbit? While the solar wind does not have the strength to change the trajectories of large planetary bodies, its influence on smaller objects, such as comets, can be more pronounced. The interaction of the solar wind with the comets could have altered their orbits in ways that contributed to their simultaneous arrival. As comets approached the inner solar system, they would have experienced stronger solar winds that could slightly shift their paths, pushing them into the solar system's gravitational well. In addition to the solar wind, the Sun's gravitational force plays a dominant role in shaping the movement of objects within the solar system. All of the planets, asteroids, and comets in the solar system are gravitationally bound to the Sun, and their orbits are shaped by its pull. As comets move through the solar system, the gravitational influence of the Sun is what governs their paths. However, there are instances where gravitational interactions with other massive bodies, such as Jupiter or Saturn, can alter the path of a comet. These gravitational encounters are particularly relevant for comets originating in the Oort cloud, a distant region at the edge of the solar system, or the Kuiper belt, which lies just beyond Neptune. As comets from these regions move inward toward the Sun, they can be perturbed by the gravitational fields of the outer planets, changing their orbits and sending them on paths that take them closer to the inner solar system. The 7 comets of 2025, many of which passed near Earth and Mars, may have had their orbits altered by the gravitational influence of planets, particularly the gas giants, such as Jupiter. Known as planetary nudges, these interactions can dramatically change the course of a comet, redirecting it toward Earth's orbit. This type of gravitational influence could explain why several comets arrived in close proximity to Earth in the same year. It is likely that these comets had been traveling for millions of years, and only recently did they encounter the right gravitational influences that directed them toward the solar system's inner region. The possibility that these comets' orbits were influenced by gravitational forces acting on them years or even centuries before they arrived at Earth is an exciting avenue of exploration. Could the gravitational interactions of the solar system's giant planets be the hidden force that caused these comets to converge in 2025? This idea is a compelling one and could provide the missing link in understanding why the 7 comets arrived at roughly the same time. While the Sun and its gravitational influence are the most obvious factors shaping the movement of comets within the solar system, the possibility that objects from outside our solar system, like 3I Atlas, could have an impact is a compelling theory. 3I Atlas, a fast-moving interstellar object, passed through the solar system in 2025. And its high velocity and unique trajectory make it a candidate for influencing the comets arriving around the same time. One of the most intriguing aspects of 3I Atlas's passage through the solar system is its velocity. Unlike typical objects that are gravitationally bound to the Sun, 3I Atlas entered the solar system with such speed that it could not be captured by the Sun's gravity. Instead, it followed a hyperbolic trajectory that took it in and out of the solar system in a relatively short period of time. The sheer velocity of 3I Atlas made it an unusual interstellar object in terms of both its interaction with the solar system and its potential to influence nearby objects. Could the passage of 3I Atlas have altered the trajectories of the 7 comets? While 3I Atlas was much smaller than the Sun and far less massive than Jupiter, it is possible that its high velocity, combined with the gravitational forces at play as it passed through the solar system, could have had a subtle influence on the orbits of other objects. The gravitational pull of an interstellar object, while weaker than that of the Sun or Jupiter, can still have an effect on smaller bodies like comets. One theory is that 3I Atlas's passage through the solar system created a kind of wake that affected the comets' paths, pulling them into the inner solar system. This hypothesis is intriguing because it suggests that 3I Atlas, as a transient interstellar object, could have a larger role in shaping the dynamics of the solar system than previously thought. Its gravitational pull might have been just strong enough to nudge the orbits of nearby comets, sending them on trajectories that intersected with Earth's orbit. In addition to its gravitational pull, the passage of 3I Atlas through the solar system might have involved electromagnetic forces that could have influenced nearby objects. If 3I Atlas moved at high speeds through space, it could have generated electromagnetic fields that interacted with the solar wind and the charged particles around comets. Comets are known to interact with the Sun's electromagnetic fields, and their tails are shaped by the solar wind. Could 3I Atlas, with its interstellar origin, have created electromagnetic disturbances as it passed through the solar system, influencing the comets in ways that we don't fully understand? The idea that interstellar objects could generate electromagnetic fields capable of affecting comets is speculative, but certainly worth exploring. If 3I Atlas was exerting some kind of electromagnetic influence, it could have played a part in the surge of comets arriving in 2025. The possibility that 3I Atlas could be exerting an influence on nearby comets is not entirely far-fetched. Scientists are still studying how interstellar objects behave when they encounter the solar system, and the data gathered from 3I Atlas's passage could provide critical insights into the effects that such objects may have on comets and other bodies in the solar system. The solar system, as vast as it may seem, is still part of a larger cosmic web. Our location within the Milky Way galaxy, the movement of our solar system through interstellar space, and the interaction of our system with nearby star systems could all contribute to the sudden influx of comets and other interstellar objects. The solar system is currently moving through a relatively quiet region of the Milky Way, known as the local bubble, a vast region of space with relatively low density. This position, however, is not static. The solar system moves in an elliptical orbit around the galactic center, and over time, our path through the galaxy will bring us closer to denser regions of space. This means that our solar system could be periodically exposed to more cosmic traffic as it crosses through different regions of the galaxy. Could the timing of the 7 comets' arrival in 2025 be linked to the solar system's position within the galaxy? If the solar system is moving through a region of space with a higher density of interstellar objects, it might explain why so many comets appeared within such a short period of time. The movement of the solar system through different galactic environments could be a long-term driver of cosmic traffic, with comets and other objects appearing in waves as we cross through denser or less dense regions of space. In addition to the solar system's movement through the galaxy, the gravitational influence of nearby star systems could also play a role in the surge of comets. Stars do not exist in isolation, but are part of larger galactic structures, such as star clusters or stellar associations. As the solar system moves through space, it may occasionally pass near other star systems, which could influence the orbits of objects in the Oort cloud or Kuiper belt. The movement of the solar system through these regions may periodically cause a ripple effect, pushing comets toward the inner solar system. This theory suggests that the appearance of the 7 comets in 2025 might not be a one-off event, but rather part of a cycle driven by the solar system's position within the galaxy. As we continue to move through different parts of the galaxy, we may continue to encounter other waves of cosmic objects, leading to similar events in the future. The surge of 7 comets in 2025 has highlighted the importance of monitoring the skies and improving our ability to detect and track cosmic objects. While comets are often discovered by accident or through long-term observations, the sudden appearance of multiple comets in such a short time underscores the need for enhanced tracking systems and more advanced telescopes. Current sky surveys are effective at detecting near-Earth objects, NEOs, such as asteroids and comets, but the detection of interstellar objects and distant comets requires more advanced technologies. One of the key challenges is the speed at which interstellar objects like 3I Atlas travel. Unlike NEOs, which follow predictable orbits and move slowly relative to the Earth, interstellar objects move at incredibly high velocities, making them harder to detect and track. To improve our ability to detect these objects, astronomers are looking towards space-based observatories, such as the James Webb Space Telescope, which can monitor deep space with greater precision. These observatories, coupled with advanced algorithms and artificial intelligence, AI, will allow scientists to track interstellar objects as they enter the solar system and better understand their origins and behaviors. Given the potential threat posed by interstellar objects and the need for accurate tracking, international cooperation will be critical in improving space surveillance. Space agencies around the world must work together to share data and resources in order to detect and track cosmic traffic more effectively. This collaboration will help create a more comprehensive and unified approach to planetary defense, ensuring that humanity is better prepared for future encounters with interstellar objects. The passage of 7 comets through the solar system in 2025 has raised more questions than answers, but it has also sparked a new era of cosmic exploration. From the potential gravitational influence of 3I Atlas to the solar system's galactic position, the theories surrounding this surge of comets highlight how little we truly understand about the forces shaping the universe. As we continue to track these objects and refine our models of the solar system and interstellar space, we move closer to understanding the true dynamics of the galaxy. What we know for sure is that the universe is full of surprises, and the appearance of these 7 comets is just the beginning of our journey to uncover the mysteries of cosmic traffic. The sudden surge of 7 comets in 2025 was not only a puzzling event, but also a reminder of the critical importance of technological advancement in space science. While astronomers have been tracking comets and asteroids for centuries, the appearance of so many comets in such a short time span has revealed significant gaps in our current monitoring systems. The need for more advanced detection and tracking technologies has never been clearer, especially as interstellar objects like 3I Atlas and other distant comets begin to visit our solar system. Traditionally, the detection of comets and other celestial objects has relied on ground-based observatories, which use optical telescopes to scan the skies. While these systems have been remarkably effective in detecting objects that pass close to the Earth, their range is limited. Telescopes on the ground are hampered by Earth's atmosphere, which distorts the clarity of observations, especially for objects far out in space. This issue becomes even more pronounced for interstellar objects and comets coming from the farthest reaches of the solar system, as they are often faint and difficult to spot. The recent surge of comets in 2025 highlighted just how difficult it is to track these objects far in advance. For example, several of the 7 comets weren't detected until they were already on their way toward the Sun or nearing the Earth. This late detection left scientists with a narrow window of time to observe their behavior, assess their potential for impact, and predict their future movements. While traditional telescopes continue to serve as important tools in space observation, new technologies are required to enhance our ability to track objects at greater distances and with more precision. As the number of objects entering the solar system from beyond its borders increases, it is vital that we develop systems capable of identifying these objects earlier, providing astronomers with the necessary time to study their trajectories and prepare for any potential risks. One promising solution to these detection challenges lies in the development of space-based telescopes. Unlike their ground-based counterparts, space-based observatories are free from the distorting effects of Earth's atmosphere and can scan the skies with far greater clarity. The most notable example of this is the James Webb Space Telescope, JWST, which is capable of observing distant regions of space in infrared wavelengths. With its ability to detect faint objects from far beyond the solar system, JWST is well suited for detecting interstellar objects like 3I Atlas and comets from the Oort cloud or Kuiper belt. In addition to the JWST, other upcoming space missions like the Nancy Grace Roman Space Telescope, (ROMAN), and the Wide Field Infrared Survey Telescope, WFIRST, are expected to play significant roles in improving our ability to monitor the cosmos. These telescopes will help astronomers identify objects that might otherwise go unnoticed, and they will provide invaluable data on the behavior and composition of comets and interstellar objects. With better technology, we can track these objects years before they make their way into the inner solar system, giving scientists ample time to study their characteristics and predict their trajectories with greater accuracy. As the number of objects entering the solar system continues to rise, artificial intelligence, AI, and machine learning are expected to become indispensable tools in the detection and analysis of comets and interstellar objects. While astronomers are capable of processing large amounts of data, the sheer volume of observations collected by modern telescopes often requires automated systems to identify potential threats or interesting objects. AI algorithms can be trained to recognize patterns in the data, automatically flagging objects that warrant further investigation. For instance, AI can be used to analyze the data collected by space-based observatories, processing thousands of images and spectral readings in a fraction of the time it would take a human scientist. By doing so, AI can help prioritize objects that are of particular interest, such as those that are on a trajectory toward Earth or those that exhibit unusual characteristics. This could significantly reduce the time it takes to identify important objects and allow scientists to respond more quickly to unexpected cosmic events. Machine learning algorithms can also help improve the accuracy of predictive models, enabling astronomers to forecast the paths of comets and interstellar objects with greater precision. With improved tracking and data analysis capabilities, we will be better equipped to study and understand the behavior of these objects, ensuring that we are prepared for future encounters. As the appearance of the 7 comets in 2025 shows, cosmic traffic is a reality that humanity must learn to deal with. While the risk of an impact with Earth remains relatively low, the consequences of such an event could be catastrophic. The high velocities of comets and interstellar objects, combined with the immense energy they carry, mean that even a small object could cause significant damage if it were to collide with Earth. The question then becomes, how can humanity prepare for future encounters with cosmic objects? The threat posed by comets and asteroids has been a topic of concern for scientists for many years. While large-scale impact events are rare, the potential damage they can cause is immense. For instance, the impact of a comet or asteroid could result in widespread fires, tsunamis, and a significant shift in the Earth's climate, leading to mass extinctions. The 7 comets of 2025, though not a direct threat to Earth, serve as a reminder of how vulnerable our planet is to the unpredictable nature of the cosmos. If an interstellar object like 3I, Atlas, or a massive comet were to collide with Earth, the consequences would be catastrophic. While the likelihood of such an event occurring in the near future is low, it's important that we begin to take proactive steps to prepare for the possibility. In recent years, space agencies around the world have begun to develop planetary defense systems aimed at detecting and mitigating the risk of impacts from comets, asteroids, and other celestial bodies. These systems are designed to track near-Earth objects, NEOs, and, if necessary, deflect them before they can cause harm to the planet. The most well-known planetary defense mission is NASA's Planetary Defense Coordination Office, PDCO, which works to detect, track, and characterize NEOs. The office is responsible for monitoring the skies for objects that could potentially pose a threat to Earth. In the event that an object is identified as a potential risk, the PDCO can help coordinate efforts to develop and implement strategies to prevent an impact. One possible method for deflecting an asteroid or comet is the use of kinetic impactors, which involves sending a spacecraft to collide with the object at high speed, altering its trajectory. Another potential method is nuclear deflection, which involves using a nuclear explosion to change the object's course. While these techniques are still in the early stages of development, they represent critical tools in the fight to protect Earth from potential cosmic threats. The arrival of interstellar objects like 3I Atlas presents a unique challenge for planetary defense. Unlike objects that are part of the solar system and bound by the sun's gravity, interstellar objects travel at much higher velocities and can approach the solar system from any direction. This makes them far more difficult to detect and track, as their paths are less predictable and can be much faster. To prepare for interstellar threats, humanity will need to develop new detection systems capable of identifying these objects at much greater distances. Current telescopic surveys are designed to detect NEOs, but the rapid movement of interstellar objects makes them harder to spot until they are already in the inner solar system. Developing space-based telescopes that can scan the vast regions of interstellar space and detect incoming objects earlier will be essential for improving planetary defense capabilities. Moreover, as the number of interstellar objects passing through the solar system increases, it will be important to develop new strategies for mitigating the risks associated with these objects. Understanding the behavior of interstellar objects and their potential to interact with the solar system is crucial for ensuring that humanity is prepared for future encounters. The passage of 7 comets in 2025 also raises an important question. Could these objects, and others like them, carry the building blocks of life? Many of the comets observed in 2025 exhibited unusual chemical compositions, including organic molecules like cyanogen and carbon dioxide. Could these molecules be the seeds of life, traveling across the galaxy and potentially seeding planets with the necessary ingredients for life to form? The theory of panspermia posits that life, or at least the building blocks of life, could spread across the galaxy on comets, asteroids, and other celestial objects. This idea suggests that life on Earth might have originated from microorganisms or organic compounds that were carried here by a comet or asteroid from another star system. While the theory remains speculative, it has gained traction in recent years, particularly with the discovery of organic molecules on comets and other celestial bodies. Could the comets of 2025 be carrying the ingredients for life that were formed in distant star systems? The presence of cyanogen in some of the comets observed in 2025 suggests that the building blocks of life might be more common throughout the galaxy than we once thought. Cyanogen, which contains carbon and nitrogen, is essential for the formation of amino acids, proteins, and other biological molecules. The discovery of this compound in interstellar objects raises the tantalizing possibility that life could be more widespread than we ever imagined. The study of comets and interstellar objects is crucial not only for understanding the origins of life on Earth, but also for the search for life beyond our planet. If comets are capable of carrying the building blocks of life across the galaxy, it stands to reason that life could exist on other planets and moons in distant star systems. As astronomers continue to study comets and other celestial bodies, they will be looking for signs of organic molecules, amino acids, and other compounds that are essential for life. This search for life beyond Earth is one of the most profound endeavors in science, and the study of interstellar objects like 3I Atlas will be an important part of that search. As we develop the technology to study these objects in more detail, we may one day uncover evidence of life's building blocks in distant star systems, opening up new possibilities for the existence of life elsewhere in the galaxy. The surge of 7 comets in 2025 has captured the imagination of astronomers and the public alike. While the mystery of their simultaneous arrival remains unsolved, the event has raised important questions about the forces that shape the solar system and the broader galaxy. From the gravitational influence of the giant planets to the potential role of interstellar objects like 3I Atlas, we're beginning to understand how interconnected the universe truly is. As we continue to study comets and other cosmic visitors, we must also prepare for the future. The development of better detection systems, planetary defense strategies, and the search for extraterrestrial life will be crucial in ensuring that humanity is ready for the challenges and opportunities posed by these cosmic events. The study of these 7 comets is just the And the discoveries we make in the years to come will continue to shape our understanding of the universe and our place within it. The arrival of 3I Atlas, the first confirmed interstellar object to pass through the solar system, has fundamentally altered our understanding of the solar system's position in the galaxy and our relationship with objects from other star systems. Prior to its arrival, the solar system was often seen as an isolated, relatively static entity, an arrangement of planets and smaller bodies orbiting a single star. However, 3I Atlas's passage has shattered that perception, making it clear that the solar system is not an island, but part of a dynamic, interconnected galactic system, where interstellar objects can and do pass through, bringing with them a wealth of scientific potential. Before 3I Atlas, objects from outside the solar system were purely theoretical. Their existence was speculated upon, but had never been observed until this remarkable interstellar visitor. The fact that 3I Atlas was detected and studied during its brief time in the solar system has opened the door to new questions. How often do such objects pass through our solar system? What forces allow them to travel such great distances? And what can we learn from studying their properties? The passage of 3I Atlas also sparked new discussions about the potential for interstellar travel, the behavior of interstellar objects, and their potential to affect our understanding of space. For astronomers, the fact that an object from another star system could enter the solar system and pass through relatively unharmed is a remarkable event that underscores the vastness of space and the complex interactions that occur on cosmic scales. But beyond this, it has also prompted questions about the stability of the solar system. Could the gravitational influence of an interstellar object like 3I Atlas have subtle effects on the paths of planets, moons, or smaller bodies? Could it nudge objects from the Oort cloud, bringing them toward the inner solar system? These kinds of interactions will be an area of great interest moving forward. As humanity looks to deepen its understanding of space, it is clear that the study of interstellar objects like 3I Atlas will become an increasingly important part of that journey. Moreover, it raises the prospect of studying other interstellar objects that may pass through in the future, offering a rare and invaluable opportunity to understand the forces shaping the galaxy. As 3I Atlas made its way through the solar system, it provided astronomers with an unprecedented opportunity to study an object that had never before been influenced by the Sun's gravitational pull. Unlike comets and asteroids from within the solar system, 3I Atlas had traveled across vast stretches of interstellar space, untouched by the forces that govern our cosmic neighborhood. By studying its chemical composition, trajectory, and the way it interacted with the solar wind and other forces, astronomers gained valuable insights into the nature of interstellar objects and the broader processes at play in the galaxy. One of the most exciting aspects of 3I Atlas was its chemical composition, which provided a unique glimpse into the materials that exist in other star systems. Unlike comets from the Oort cloud or Kuiper belt, which primarily contain water ice, carbon monoxide, and methane, 3I Atlas exhibited a mix of compounds that had never been observed in solar system comets. In particular, the presence of cyanogen, a molecule composed of carbon and nitrogen, was especially significant. Cyanogen is toxic to life on Earth, but it is also a key building block of amino acids, the essential components of proteins. The discovery of cyanogen in 3I Atlas raised the tantalizing possibility that the conditions for life in distant star systems may be more common than previously thought. If interstellar objects like 3I Atlas can carry these compounds across the vast distances between stars, it suggests that the building blocks for life may be more widespread than we realize. Could it be that life's essential ingredients are scattered throughout the galaxy, waiting to be discovered? In addition to cyanogen, 3I Atlas contained other compounds, including carbon dioxide, ammonia, and methane. These compounds are common in the outer regions of the solar system, but are less frequently found in comets from the Oort cloud or Kuiper belt. The presence of such a diverse chemical mixture suggests that 3I Atlas originated in a star system with conditions very different from our own. Perhaps the temperature, radiation levels, or the composition of the gas and dust in its parent system influence the chemistry of the object. By studying the chemical makeup of 3I Atlas, astronomers gained insights not just into the conditions of its home star system, but also into the broader processes of star and planet formation. The elements found in 3I Atlas can provide clues to the types of materials that exist in other star systems, and how those materials might form planets, moons, or other celestial bodies. One of the most fascinating questions about 3I Atlas is its origin. Unlike comets and asteroids that are part of the solar system, 3I Atlas came from another star system entirely, traveling across interstellar space for millions of years before entering the solar system. The fact that it was able to travel such vast distances without being disrupted by other forces in the galaxy is a testament to the remarkable resilience of these objects and the forces at play in the interstellar medium. While 3I Atlas is an interstellar object, the materials it contains may still have been formed in regions not entirely unlike those found within our solar system. It's possible that 3I Atlas's origins are tied to the outer regions of its home star system, much like comets in the solar system come from the Oort cloud or the Kuiper belt. The Oort cloud is a region of icy bodies that extends far beyond Pluto, while the Kuiper belt is a more compact region just beyond Neptune. These regions are thought to be the birthplace of many comets, and objects that are ejected from these areas can travel across the galaxy, sometimes even entering other star systems. While 3I Atlas's composition suggests that it did not originate in the solar system, it is possible that it was once part of a distant star system with similar conditions. Could it have been ejected from its home system during the formation of its star, or perhaps as the result of a gravitational disturbance? The fact that 3I Atlas is a relatively small object, yet capable of surviving millions of years of interstellar travel, suggests that there may be a population of similar objects scattered throughout the galaxy, waiting to pass through other star systems in the future. The passage of 3I Atlas has provided scientists with an unprecedented opportunity to study an object that has never been influenced by the gravity of the Sun or any of the solar system's planets. This makes it an invaluable specimen for astronomers looking to understand how objects from other star systems are affected by the interstellar medium. 3I Atlas's high velocity and unusual trajectory indicate that it is a truly interstellar object, one that has been traveling across the galaxy for a long time. One possible explanation for its interstellar journey is that 3I Atlas was ejected from its parent star system during the formation of its star or as a result of a nearby star's gravitational influence. The process of star formation is often violent, with massive gravitational forces at play. Objects like 3I Atlas can be sent hurtling through space, traveling across vast distances before eventually reaching another star system, where they may be detected and studied by astronomers. Understanding the origins of objects like 3I Atlas could help us better understand the process of star and planet formation in other star systems. The more we learn about these objects, the closer we get to understanding how planets and other bodies form around other stars, and whether life could exist elsewhere in the galaxy. While 3I Atlas's passage through the solar system was a fascinating scientific discovery, it also raised important questions about the vulnerability of the solar system to interstellar objects. As interstellar visitors continue to pass through our cosmic neighborhood, we must consider the potential risks they pose to Earth and the other planets in our system. While the vast majority of interstellar objects, like 3I Atlas, pass through the solar system without any significant impact, the potential for a catastrophic event remains. A large interstellar object, moving at speeds far greater than typical solar system comets, could cause widespread destruction if it were to collide with Earth. While such events are rare, the sheer energy carried by these objects could have devastating consequences. The likelihood of a large interstellar object striking Earth is relatively low, but the possibility is real. Even smaller objects could cause significant damage if they collided with the planet. The speed and trajectory of these objects make them especially difficult to track, and their sudden appearance means that we have little time to respond to potential threats. The study of interstellar objects like 3I Atlas is crucial for understanding how these objects interact with the solar system and what kind of damage they might cause if they were to collide with a planet. Given the potential risks posed by interstellar objects, planetary defense systems must be prepared for the possibility of future interstellar visitors. Currently, space agencies around the world are focused on detecting and tracking near-Earth objects, NEOs, such as asteroids and comets. However, the detection of interstellar objects requires new technologies and strategies. Unlike NEOs, which follow relatively predictable orbits and can be tracked years in advance, interstellar objects arrive from any direction and at much higher speeds. This makes them more difficult to detect and track. As 3I Atlas's passage demonstrated, we need more advanced detection systems, including space-based telescopes, to identify these objects as early as possible and track their movements. In addition to detection, we also need to develop planetary defense strategies for dealing with potential impacts from interstellar objects. Technologies like kinetic impactors or nuclear deflection systems may one day be needed to prevent a collision with a large interstellar object. While such technologies are still in the early stages of development, they represent important tools for ensuring the safety of Earth in the future. As humanity looks toward the stars and plans for the exploration of distant planets and moons, the study of interstellar objects like 3I Atlas will play a crucial role in shaping the future of space travel. These objects provide a unique opportunity to study the conditions of interstellar space and the behavior of objects from other star systems. By understanding how interstellar objects interact with the solar system, we can better prepare for future missions to explore the stars. The study of interstellar objects has already led to new ideas for interstellar exploration. If objects like 3I Atlas can travel across the galaxy, then it stands to reason that humanity might one day develop the technology to send probes or even humans to other star systems. While this may sound far-fetched, the study of objects like 3I Atlas is a crucial step in understanding how interstellar travel could become a reality. The next frontier of space exploration lies beyond the solar system, and the insights gained from studying interstellar objects will be key in making that leap. If we can learn how to track, study, and eventually intercept interstellar objects, we will be one step closer to developing the technology required for interstellar travel. As we continue to study these visitors from other stars, we are also laying the groundwork for humanity's journey beyond the solar system. The passage of 3I Atlas through the solar system is just the beginning. As we continue to study the arrival of interstellar objects, we will unlock more secrets about the universe and our place in it. The event has challenged our understanding of the solar system, revealing just how interconnected the universe is and how much we still have to learn about the forces that govern cosmic behavior. While the 7 comets of 2025 may have appeared to be a rare coincidence, the possibility of a hidden connection between them points to the deeper mysteries of the cosmos. By continuing to study interstellar objects like 3I Atlas, we will better understand the dynamics of the galaxy, the potential for life beyond Earth, and how our solar system fits into the larger cosmic tapestry. As humanity looks to the stars, the study of interstellar objects will be an essential part of that journey. We are only just beginning to explore the vastness of space, and the discoveries of tomorrow may be even more extraordinary than those of today. The surge of 7 comets in 2025 was more than just a remarkable celestial event. It was an opportunity for astronomers and space agencies worldwide to study how objects from beyond the solar system behave when they encounter the sun's gravity and the solar wind. The clustering of these objects provides scientists with a rare and valuable opportunity to investigate the interactions between the solar system and interstellar objects. But as exciting as the discovery was, it also raised new questions. Was this just an anomaly, or were there larger, more predictable patterns at play in the movement of these objects? If so, what other events could be waiting to unfold in the future? Could there be other hidden cosmic phenomena driving the flow of interstellar objects into the solar system? And could the arrival of these comets signify a turning point in our understanding of cosmic dynamics? While much of the scientific community remains focused on understanding the specific trajectories and origins of these 7 comets, their appearance signals a shift in the way we approach space exploration. It demonstrates that our solar system is not as isolated as we once believed. Instead, we are part of an ever-changing and dynamic cosmos, where forces far beyond our control shape the trajectories of celestial bodies and send objects from other star systems hurtling toward us. These comets, once part of distant star systems, could serve as time capsules, providing a glimpse into the chemical composition, formation processes, and potential for life in other parts of the galaxy. But perhaps more importantly, the study of these objects challenges us to rethink our approach to space travel, planetary defense, and even our understanding of life beyond Earth. One of the key theories about the appearance of the 7 comets in 2025 lies in the nature of the Oort cloud and the Kuiper belt, 2 vast regions on the outskirts of the solar system that are known to be the birthplaces of many comets. These regions are home to a large number of icy bodies that, when disturbed, can be sent on trajectories that bring them closer to the Sun. This process of disruption is often triggered by the gravitational influence of nearby stars, rogue planets, or even interstellar objects like 3I Atlas. The Oort cloud is a theoretical region surrounding the solar system, extending far beyond the Kuiper belt, and is believed to contain trillions of icy bodies, many of which could be the progenitors of the comets that we observe in the inner solar system. The cloud's location, some 50,000 to 100,000 astronomical units (AU) from the Sun, makes it one of the most distant and least understood regions of the solar system. However, when gravitational disturbances occur, whether from passing stars, galactic tides, or other cosmic events, some of these bodies may be pulled inward toward the solar system. The arrival of multiple comets in 2025 could be a sign that something has disturbed the Oort cloud, sending comets into the inner solar system. While it is difficult to pinpoint the exact cause of this disturbance, it could be the result of a passing star or an interstellar object like 3I Atlas that altered the orbits of objects within the Oort cloud. This would explain why 7 comets arrived around the same time. They could have been part of a larger wave of objects that were affected by a cosmic event. The Kuiper belt, a region just beyond Neptune, is another significant source of comets. This region is home to many icy bodies, including dwarf planets like Pluto, and is thought to be the birthplace of short-period comets that orbit the Sun in predictable cycles. While the Oort cloud is more distant, the Kuiper belt offers a closer, more accessible pool of comets. While most comets that originate from the Kuiper belt follow stable orbits, some are perturbed by the gravitational influence of the giant planets, particularly Neptune, which can send them on highly elliptical orbits. These objects can be nudged into paths that bring them closer to the Sun, and in some cases, they can cross Earth's orbit. This kind of disruption could also explain why the comets arrived in 2025. Perhaps a recent interaction with a giant planet or a gravitational anomaly in the Kuiper belt caused several comets to follow similar trajectories into the inner solar system. Some astronomers speculate that the clustering of these comets in 2025 could signal a larger galactic shift. Perhaps the solar system is moving through a denser region of space. Or the gravitational influence of nearby star systems is starting to affect the Oort cloud and Kuiper belt. It is also possible that the passage of 3I Atlas itself could have disrupted the solar system's outer reaches, setting these comets on their current paths. While it is still too early to say whether this surge of comets is part of a regular galactic cycle, the study of their origins and trajectories could provide valuable insights into the behavior of objects in the outer solar system. The interplay between the Oort cloud, Kuiper belt, and the Sun's gravitational influence is still not fully understood, and events like the one in 2025 could reveal new patterns in the movement of these distant bodies. The surge of 7 comets, along with the passage of 3I Atlas, highlights a critical need for better planetary defense strategies. While the comets in 2025 did not pose a direct threat to Earth, the fact that interstellar objects can travel through the solar system with minimal warning underscores the potential risks associated with cosmic traffic. As these objects come from outside the solar system, their arrival is much harder to predict than asteroids or comets that are already part of the solar system. Interstellar objects like 3I Atlas travel at incredibly high velocities, sometimes reaching speeds of hundreds of kilometers per second. When objects of such velocity enter the solar system, they carry an enormous amount of kinetic energy. Even small objects can cause massive destruction if they collide with Earth, and their high speed makes them much harder to intercept or deflect using current technology. While the likelihood of a collision with Earth remains low, the potential consequences of such an event are catastrophic. The impact of an interstellar object could result in widespread fires, tsunamis, and a dramatic shift in the global climate, similar to the impact that wiped out the dinosaurs millions of years ago. As we continue to explore space and observe more interstellar objects passing through the solar system, the need for effective planetary defense systems has never been more urgent. In response to the growing threat posed by interstellar objects, space agencies around the world are beginning to invest in planetary defense strategies. While much of the focus has been on tracking and mitigating the risk of asteroids and comets, interstellar objects present a unique challenge. Their high speed and unpredictable paths make them difficult to track and even harder to deflect. One possible method for deflecting an interstellar object is the use of kinetic impactors, which involves sending a spacecraft to collide with the object and alter its trajectory. However, the high velocity of interstellar objects would require spacecraft capable of reaching much higher speeds than current technology allows. Another potential method is nuclear deflection, which would involve detonating a nuclear device near the object to alter its path. This concept is still theoretical, but it highlights the need for research and development in planetary defense technologies. As we continue to track interstellar objects and develop new defense strategies, it is clear that international collaboration will be crucial. The threat of cosmic collisions is not something any one country can tackle alone. By sharing data and resources, space agencies around the world can work together to improve detection systems, develop mitigation technologies, and prepare for the possibility of future interstellar encounters. While the arrival of 7 comets in 2025 raised concerns about planetary defense, it also provided an incredible opportunity for scientists to study the solar system's early history. Comets are often referred to as fossils of the solar system because they contain some of the oldest and most primitive materials in space. By studying the chemical composition and structure of these comets, astronomers can gain valuable insights into the conditions that existed in the early solar system. Comets are made of ice, dust, and gas, materials that were abundant in the early solar system but have since been scattered or incorporated into other objects. Because they formed in the cold outer regions of the solar system, they have remained largely unchanged over billions of years. Unlike planets and moons, which have undergone significant geological processes, comets preserve a snapshot of the solar system's conditions before it became the dynamic system we observe today. By analyzing the chemical composition of the 7 comets observed in 2025, scientists can learn more about the types of materials that were present in the early solar system and how they contributed to the formation of planets, moons, and other bodies. For example, the presence of complex organic compounds like cyanogen in some of the comets could provide clues to the early chemical processes that led to the formation of life. The discovery of organic molecules in comets is especially exciting because these molecules could be the building blocks for life. The theory of panspermia posits that life on Earth may have originated from organic molecules that were delivered by comets or asteroids. If comets in the solar system contain the same types of organic compounds as those observed in interstellar objects like 3I Atlas, it raises the possibility that life's building blocks could be more widespread in the galaxy than previously thought. In addition to their potential link to the origins of life, comets may also offer clues about the early evolution of the solar system. By studying how comets interact with the Sun's solar wind and gravitational forces, scientists can learn more about the processes that shaped the solar system's current configuration. The data gathered from these comets could help refine models of planetary formation and provide a better understanding of how our solar system came to be. As humanity continues to search for extraterrestrial life, the study of interstellar objects like 3I Atlas and the 7 comets of 2025 may be our best chance of finding answers.
The presence of organic molecules on comets and other celestial bodies raises the question, could life, or at least the building blocks for life, be more common in the universe than we previously thought? The theory of panspermia suggests that life, or at least the building blocks of life, could spread between stars via comets, asteroids, or other celestial objects. If this theory is correct, the appearance of organic molecules in comets from other star systems suggests that life's building blocks could be widespread throughout the galaxy. Objects like 3I Atlas and the 7 comets of 2025 could be carrying the very compounds that might one day lead to life on other planets.
If life can spread through space in this way, it would mean that planets around other stars might have a greater chance of developing life. This would expand the habitable zone in the galaxy and increase the likelihood that life exists elsewhere. The more we study interstellar objects like 3I Atlas and the comets that pass through the solar system, the closer we get to understanding the conditions necessary for life to exist elsewhere in the universe. The data gathered from studying interstellar objects like 3I Atlas is only the beginning. In the coming decades, space agencies will likely send missions to study comets up close, gathering even more detailed data about their chemical composition and structure. These missions could help us understand the origins of life in the universe and provide clues about the potential for life beyond Earth. By studying comets, asteroids, and other objects that pass through our solar system, we can unlock some of the greatest mysteries of the cosmos. These objects may hold the key to understanding our origins, the potential for life on other planets, and the forces that shape the galaxy. The search for extraterrestrial life is one of the most exciting scientific endeavors of our time, and the 7 comets of 2025 may play a crucial role in uncovering the truth about life beyond Earth. As we continue to study the arrival of the 7 comets in 2025, we are reminded of the vastness of the universe and the unpredictability of cosmic events. While these comets may have appeared to be a rare coincidence, their arrival has opened the door to new questions about the solar system's place in the galaxy and the forces that shape it. Whether these comets were part of a larger cosmic event, influenced by gravitational forces from the Sun, interstellar objects like 3I Atlas, or the galactic environment, one thing is certain: the universe is full of mysteries that we have only begun to explore. As we look to the future, the study of comets, interstellar objects, and the forces at play in our galaxy will continue to inform our understanding of the cosmos. From planetary defense to the search for extraterrestrial life, these events are shaping humanity's journey into the stars. The 7 comets of 2025 may be just the beginning of a much larger cosmic story that will unfold over the coming decades and centuries. The arrival of 3I Atlas in 2025 marked a historic event for astronomy. Prior to this, the idea of interstellar objects visiting our solar system was purely theoretical. The discovery of 3I Atlas confirmed that objects from other star systems could and do pass through our cosmic neighborhood. This realization opens up a new frontier for space exploration, one that goes beyond the confines of our solar system and into the vast expanse of interstellar space. For centuries, humanity has been confined to exploring our solar system, studying planets, moons, asteroids, and comets. The study of objects within our own solar system has taught us much about the origins and evolution of our cosmic neighborhood. But 3I Atlas introduced a new layer to this exploration: the possibility that objects from other star systems carry with them important clues about the formation of stars and planets far beyond our reach. The fact that interstellar objects like 3I Atlas can travel vast distances between star systems and eventually pass through the solar system has profound implications for our understanding of the universe. These objects are not bound by the Sun's gravity or the gravitational forces of our local star system. They are free to traverse space, carrying with them information about their origin and the conditions of their home star systems. For astronomers, this discovery is the beginning of a new era in space exploration. The study of interstellar objects will help refine our models of how star systems form, how planets and moons develop, and how cosmic material is distributed throughout the galaxy. As technology improves and more interstellar objects are discovered, humanity will have the opportunity to explore the very building blocks of the universe, gaining insights into its origins and its future. The discovery of interstellar objects like 3I Atlas also raises the possibility of future interstellar exploration. If objects from other star systems can reach the solar system, what would it take for humanity to travel to other star systems? Could we one day send probes or even humans to explore the stars themselves? While this may seem like a distant dream, the study of interstellar objects provides valuable data that could help make interstellar travel a reality. We are already developing technologies that might one day be able to carry humans to the nearest stars. The study of 3I Atlas and other interstellar objects can help guide the development of these technologies. For example, understanding the behavior of interstellar objects could help us design spacecraft that can withstand the harsh conditions of deep space. Learning about the materials that make up these objects can also help us refine our understanding of how to navigate interstellar space. The ultimate goal of interstellar exploration is to learn more about the stars, planets, and galaxies that surround us. By studying the objects that come to us from other star systems, we can begin to unlock the mysteries of the universe beyond our solar system, ultimately leading to a new chapter in humanity's journey into the cosmos. While 3I Atlas is a remarkable interstellar object, many of the comets observed in 2025 came from within our solar system, specifically from the Oort cloud and the Kuiper belt. These two regions, located far beyond the orbit of Neptune, are home to many icy bodies that, when disturbed, can be sent on trajectories that bring them into the inner solar system. But what causes these comets to be pulled inward? One answer lies in the immense gravitational forces exerted by the solar system's gas giants, Jupiter, Saturn, Uranus, and Neptune. Jupiter, the largest planet in the solar system, plays a key role in shaping the paths of comets and other celestial objects. Due to its massive size, Jupiter's gravity is strong enough to alter the orbits of smaller objects in the solar system, including comets. When a comet from the Oort cloud or Kuiper belt passes close to Jupiter, the planet's gravity can either deflect the comet from its path or accelerate it, sending it on a trajectory toward the Sun. This gravitational nudge is often referred to as a planetary kick, and it is responsible for sending many comets on their long journeys toward the inner solar system. The gravitational influence of Jupiter is so significant that it has been credited with redirecting comets into orbits that bring them close to Earth. In some cases, Jupiter can even capture comets and cause them to become part of the solar system's family of comets. Jupiter's ability to influence the orbits of comets is not limited to objects in the Oort cloud. It can also affect the paths of comets in the Kuiper belt, where many short-period comets originate. By altering the trajectories of these objects, Jupiter can influence the timing and location of their appearances, sometimes causing multiple comets to arrive in the solar system in a short period of time. This gravitational interaction may have contributed to the surge of comets in 2025, particularly if Jupiter was in a position to influence the orbits of comets from the outer reaches of the solar system. While Jupiter is the most powerful planet in terms of gravitational influence, the outer giants, Saturn, Uranus, and Neptune, also exert significant forces on objects in the solar system.
These planets, though farther from Earth, are still large enough to affect the orbits of comets and other bodies that pass through the outer solar system. Saturn's gravity can deflect comets from their original paths, much like Jupiter, while Uranus and Neptune can have more subtle effects on the orbits of comets in the Kuiper belt. While their influence may not be as pronounced as Jupiter, their combined gravitational effects on the outer solar system can result in the clustering of comets, particularly those on the fringes of the solar system. If multiple comets are being pulled toward the inner solar system by the gravitational forces of the gas giants, it could explain why several comets arrived near Earth and Mars in the same year. Jupiter's influence in particular may have caused these comets to converge, bringing them on paths that intersect with Earth's orbit. To understand why comets like those seen in 2025 suddenly appear near Earth, it's essential to explore the origin of these objects. The Oort cloud is a massive spherical region of icy bodies that lies far beyond the orbit of Pluto. It is believed to be the source of most long-period comets, including those that make their way to the inner solar system. These comets, though often invisible, can become visible when they are disturbed from their orbits and sent toward the Sun.
The Oort cloud is thought to be a remnant of the early solar system, formed by the same processes that created the planets. It is composed of icy bodies, comets, dwarf planets, and other small celestial objects that are made up of frozen water, methane, and ammonia. These bodies are thought to be remnants of the solar system's formation, left behind after the planets and moons took shape. The Oort cloud extends from about 2,000 to 100,000 AU from the Sun, making it the farthest known region of the solar system. The sheer distance of the Oort cloud from Earth means that most of the objects within it remain undetected by current observational tools. However, when one of these objects is perturbed, either by the gravitational influence of a nearby star or a large object like Jupiter, it can be sent on a long, elliptical orbit toward the inner solar system. The arrival of 7 comets in 2025 may be linked to a disturbance in the Oort cloud. Objects within this region are loosely bound to the Sun, and their orbits can be altered by gravitational forces from nearby stars, the galactic tide, or the passage of interstellar objects like 3I Atlas. When these objects are nudged out of their orbits, they enter the solar system, traveling on paths that bring them closer to Earth and other planets. It is possible that the gravitational influence of 3I Atlas or another nearby star has disturbed the Oort cloud, sending a cluster of comets toward the inner solar system. This could explain why multiple comets arrived in close succession rather than appearing at random over the course of several years. The study of comets that pass through the solar system, particularly those originating from the Oort cloud, offers astronomers valuable insights into the composition of the early solar system. The chemical signatures of these comets contain clues to the materials that existed during the formation of the planets, helping scientists piece together the history of our cosmic neighborhood. The Sun plays a central role in shaping the behavior of comets, as its gravitational pull and solar wind affect objects in the outer solar system. However, the Sun's activity, its solar flares, coronal mass ejections (CMEs), and the overall intensity of its solar wind can have a profound impact on the paths and behaviors of comets as they make their way through the solar system. As comets approach the Sun, the solar wind, a continuous flow of charged particles emitted by the Sun, interacts with the comet's icy nucleus, causing it to vaporize. This process creates the bright glowing coma that surrounds the comet's nucleus and the long, spectacular tail that trails behind it. The solar wind also causes the tail to point away from the Sun, even when the comet is moving in the opposite direction. However, the intensity of the solar wind can vary depending on the Sun's activity.
During periods of heightened solar activity, such as during a solar maximum, the solar wind is stronger, and this can cause comets to experience more significant changes in their tails or orbits. Solar flares and
CMS, explosions on the Sun's surface that release large bursts of energy, can also affect the behavior of comets, especially those that are within the solar system. These bursts of energy can cause comets to brighten dramatically or alter their paths, making them more visible to observers on Earth. The solar activity in 2025 could have played a role in the surge of comets observed that year. If the Sun was particularly active, it could have influenced the paths of comets, especially those in the Oort cloud and Kuiper belt. Strong solar winds, along with the gravitational influences of the gas giants, could have altered the orbits of comets, causing them to arrive near Earth and Mars at the same time. Understanding the Sun's impact on comets is essential for predicting the behavior of these objects in the future. By tracking solar activity and observing how it affects comets, astronomers can gain a better understanding of how the solar wind and solar flares influence the movement of comets and other celestial bodies. While the surge of 7 comets in 2025 did not pose a direct threat to Earth, it has underscored the need for preparedness in the face of potential cosmic risks. The solar system is constantly bombarded by objects from the outer reaches of space. And while most of these objects are small and harmless, the possibility of a catastrophic impact remains a real concern. The appearance of these comets, along with the potential for future interstellar visitors, highlights the importance of planetary defense. While comets like those observed in 2025 did not pose an immediate risk, larger objects that pass through the solar system could have devastating consequences if they were to collide with Earth. The threat of such a collision, while rare, necessitates the development of planetary defense systems to detect and mitigate the risks posed by asteroids, comets, and other celestial bodies. International space agencies have already begun working on planetary defense strategies, including early detection systems, deflection technologies, and impact mitigation measures. The study of comets like those seen in 2025 will be critical for refining these strategies and ensuring that humanity is prepared for any potential future threats from space. As more interstellar objects are detected and studied, scientists will need to develop more advanced systems for tracking and responding to cosmic threats. The surge of 7 comets in 2025 has highlighted the importance of improving early detection systems such as space-based telescopes and AI-driven algorithms to spot potential hazards well before they enter the inner solar system. By detecting these objects early, space agencies will have more time to develop a response, whether that involves deflecting the object or preparing for an impact. Planetary defense is a global challenge that requires international collaboration. By sharing data, resources, and expertise, space agencies around the world can work together to protect Earth from cosmic threats, ensuring that humanity is prepared for the unexpected. The study of the 7 comets in 2025 also has profound implications for the search for extraterrestrial life. The discovery of organic molecules in these comets raises the possibility that life's building blocks could be more widespread in the galaxy than we once believed. If comets can carry organic molecules across vast distances, it stands to reason that the ingredients for life could be delivered to other planets and moons in distant star systems. The theory of panspermia suggests that life, or at least the building blocks of life, could spread between stars via comets, asteroids, or other celestial objects. This idea has long been a topic of debate among scientists, but the discovery of organic compounds like cyanogen in the comets of 2025 lends support to the hypothesis. If the raw materials for life can travel across the galaxy on comets, it raises the possibility that life might not be confined to Earth, but could exist elsewhere in the universe. The idea that life could spread between stars through cosmic traffic would significantly expand the possibilities for life beyond Earth. As we continue to study comets and other objects from outside the solar system, we may one day find evidence that life exists on other planets or moons, potentially altering our understanding of what it means to be human. The 7 comets that arrived in 2025 were not simply isolated visitors. They were part of a larger cosmic traffic that is an ongoing and unpredictable phenomenon. These comets, along with other objects that periodically make their way through the solar system, highlight the dynamic and ever-changing nature of space. The more scientists study these objects, the clearer it becomes that the solar system is not as isolated as we once thought. In fact, it is a part of a much larger, interconnected cosmic web where objects from other star systems, distant regions of our galaxy, and even intergalactic space interact and cross paths. While 7 comets appearing in one year is certainly a rare event, astronomers are beginning to realize that the solar system is constantly being visited by objects from beyond its borders. Objects from the Oort cloud and Kuiper belt, as well as interstellar visitors, make their way through the solar system with surprising frequency. The appearance of these objects, though infrequent, is part of a regular cosmic traffic pattern that we are just beginning to understand. The study of interstellar objects, like 3I Atlas, has shown us that the solar system is not a static, isolated system, but rather part of a galactic network of stars, planets, and other celestial bodies. The motion of the solar system through the galaxy means that we are constantly interacting with objects from other star systems, and these interactions can have profound effects on the system's dynamics. The appearance of 7 comets in 2025 may not be a singular event, but rather part of an ongoing cosmic pattern that repeats itself over time. One theory is that the solar system periodically passes through regions of space with higher concentrations of objects, such as cometary swarms or interstellar gas clouds. These regions could be responsible for sending comets into the inner solar system, where they become visible to astronomers. As the solar system moves through different parts of the galaxy, it may encounter different regions of space that influence the appearance and behavior of objects like comets. The surge of comets in 2025 could therefore be part of a larger, more predictable cosmic cycle, one that we are just beginning to observe and study. The concept of cosmic traffic as a regular cycle is not new. Throughout the history of the solar system, astronomers have observed that comets tend to appear in bursts, with some years seeing multiple comets and others seeing none. These patterns could be indicative of a larger, underlying celestial movements that we are only now beginning to understand. Just as the solar system orbits the Sun and the stars orbit the galactic center, the solar system itself may be part of a larger galactic cycle that influences the appearance of cosmic objects. This idea suggests that cosmic events like the surge of 7 comets in 2025 could be part of a much larger, cyclical pattern that repeats over thousands or even millions of years. The study of past cometary activity and the tracking of interstellar objects may reveal this larger pattern, giving us new insights into the dynamics of the galaxy and the forces that govern the movement of objects through space. One of the key factors in understanding the surge of comets in 2025 is the gravitational influence of neighboring star systems. The solar system, as vast as it is not isolated from the rest of the galaxy. In fact, the motion of our solar system through space brings it into close proximity with other star systems, whose gravitational forces can impact the paths of objects in the Oort cloud, Kuiper belt, and even the inner solar system. The solar system is currently traveling through a region of space known as the local bubble, a large area of lower density gas and dust. However, this region is not empty. There are stars scattered throughout the galaxy that are constantly exerting gravitational forces on objects in the Oort cloud, Kuiper belt, and Kuiper belt.
Some of these stars are much closer to the solar system than others, and their gravitational pull can alter the orbits of nearby comets and other objects. Astronomers believe that the gravitational influence of nearby stars is a key factor in sending comets from the Oort cloud toward the inner solar system. The Oort cloud is a vast spherical region that contains trillions of icy bodies, many of which remain undisturbed for billions of years. However, when a nearby star passes close enough, its gravity can perturb these objects, sending them on long journeys toward the Sun.
This phenomenon could explain why so many comets arrived in 2025. If the solar system happened to pass near a star or stellar remnant that exerted gravitational forces on the Oort cloud, it could have sent a cluster of comets on their way toward the inner solar system. The fact that multiple comets arrived at the same time suggests that there may have been a recent gravitational disturbance that affected the paths of several objects at once. In addition to the gravitational forces exerted by individual stars, the solar system is also influenced by the gravitational pull of the entire galaxy. This force, known as the galactic tide, is a slow but constant influence on the motion of objects in the solar system. The galactic tide is caused by the collective gravitational pull of all the stars in the Milky Way, as well as the supermassive black hole at the galaxy's center. The galactic tide affects the solar system in subtle ways, including the orbits of objects in the Oort cloud. Over time, the galactic tide can cause objects in the Oort cloud to become perturbed, sending them on trajectories that bring them closer to the Sun. This slow, ongoing process could be responsible for the periodic bursts of cometary activity that we observe in the inner solar system. By studying the gravitational influence of nearby stars and the galactic tide, scientists are beginning to piece together how these forces shape the movement of comets and other objects. The clustering of comets in 2025 could be the result of a larger galactic process that is still not fully understood, and further research will be needed to determine the full extent of these forces. As we continue to study the surge of comets in 2025, one of the most intriguing questions is whether interstellar objects like 3I Atlas are influencing the solar system's dynamics. While 3I Atlas was not responsible for the appearance of the comets, its passage through the solar system has drawn attention to the potential influence of interstellar objects on our cosmic neighborhood. Could objects like 3I Atlas be more than just passing visitors? Could they have a lasting impact on the solar system's structure? One of the primary ways that interstellar objects can influence the solar system is through their gravitational pull. When an interstellar object like 3I Atlas passes through the solar system, its high velocity and mass can exert a gravitational force on nearby objects, including comets, asteroids, and even planets. While the gravitational influence of 3I Atlas was too small to cause any significant disruptions, it is possible that its passage had subtle effects on the orbits of objects in the Oort cloud or Kuiper belt. In particular, the gravitational interaction between 3I Atlas and the solar system may have disturbed the orbits of comets, causing them to enter the inner solar system. This could explain the sudden appearance of multiple comets in 2025, as they may have been influenced by 3I Atlas's passage, sending them on new trajectories toward Earth and Mars. In addition to its gravitational influence, 3I Atlas could also have an effect on the solar system's objects through electromagnetic interactions. As an interstellar object, 3I Atlas is likely to have its own magnetic field, which could interact with the solar wind and the magnetic fields of comets and other objects in the solar system. These interactions could cause changes in the behavior of the comets, such as changes in their tails or even subtle shifts in their orbits. While the electromagnetic influence of 3I Atlas is not well understood, the possibility of interstellar objects affecting the solar system in this way is an area of active research. Future missions to study interstellar objects more closely could provide valuable data on how these objects interact with the solar system's magnetic environment. While the surge of comets in 2025 did not pose a direct threat to Earth, it serves as a reminder of the vulnerability of the solar system to cosmic hazards. Interstellar objects like 3I Atlas and potentially larger objects can pass through the solar system with little warning. The high velocity and unpredictable trajectories of these objects make them difficult to detect and track. This uncertainty presents a challenge for planetary defense efforts and raises important questions about how humanity can prepare for future interstellar encounters. As the solar system continues to interact with objects from outside its borders, the need for effective planetary defense strategies becomes more urgent. While our current planetary defense efforts focus on detecting and mitigating the risk of asteroids and comets, the arrival of interstellar objects highlights the need for new technologies and methods of defense. One potential method of planetary defense is the development of advanced detection systems that can identify interstellar objects early in their approach. Space-based telescopes and advanced tracking systems could help detect these objects years before they reach the inner solar system. Early detection would give scientists more time to analyze the object's trajectory and determine if it poses a threat to Earth. In addition to detection, scientists are working on strategies to deflect or mitigate the impact of incoming objects. Techniques like kinetic impactors, where a spacecraft collides with the object to change its trajectory, are being explored, along with nuclear deflection methods. However, the high velocity of interstellar objects presents significant challenges for these strategies, as the objects would need to be intercepted at much higher speeds than typical solar system objects. Given the global nature of the threat posed by cosmic objects, international collaboration will be essential in developing effective planetary defense strategies. No single country or space agency can tackle the threat of interstellar objects alone. By sharing data, resources, and expertise, space agencies around the world can work together to monitor cosmic traffic and develop coordinated defense measures. The need for international cooperation is further emphasized by the fact that interstellar objects can originate from anywhere in the galaxy. Their unpredictable paths and high speeds make them difficult to track, and their potential to cause significant damage means that humanity must be united in its efforts to safeguard the planet. The surge of 7 comets in 2025 will undoubtedly go down as a landmark event in the history of space exploration. For astronomers, it has provided valuable data on the behavior of comets, the influence of interstellar objects, and the dynamic nature of the solar system. More than that, however, the event has deepened our understanding of the cosmos and the role of the solar system within the larger galactic ecosystem. While the comets themselves were fascinating objects in their own right, it is the questions raised by their simultaneous arrival that will continue to inspire scientific inquiry. Are these comets part of a larger cosmic cycle? Could their arrival be linked to gravitational forces from neighboring stars or the influence of interstellar objects? As we continue to study the data gathered from this event, scientists will be better equipped to answer these questions and explore the broader mysteries of the galaxy. Moreover, the surge of comets has prompted new discussions about the future of space exploration and the potential for interstellar travel. If objects like 3I Atlas can travel across the vast distances between stars, could humanity one day embark on similar journeys? The study of interstellar objects is just beginning, and the discoveries made in the wake of 2025's cosmic traffic surge could shape the future of space exploration for generations to come. Despite the advancements in space technology, the appearance of 7 comets in 2025 took astronomers by surprise. Though comets are relatively common celestial objects, the sudden and simultaneous arrival of so many within such a short period was unusual, even by cosmic standards. This event, while extraordinary, highlights a fundamental truth about the universe: that, despite our best efforts to predict its behavior, space is inherently unpredictable, and cosmic events can occur without warning. This unpredictability presents both challenges and opportunities for scientists, engineers, and space agencies around the world. Throughout history, comets have been a source of both awe and fear. Ancient civilizations often viewed comets as omens or signs of impending disaster, as their appearance was often followed by significant societal changes or natural disasters. Modern science, however, has revealed that comets are not harbingers of doom, but rather celestial objects that offer us a glimpse into the early solar system and beyond. Nevertheless, the erratic nature of their orbits and the unpredictability of their appearances have continued to intrigue astronomers. Even with the development of modern telescopes and space-based observatories, comets remain difficult to predict with precision. While we can track the orbits of many comets, some appear unexpectedly, seemingly from nowhere. The 7 comets of 2025 exemplify this. Unpredictability. Despite the sophistication of our detection systems, it was impossible to foresee that so many would converge on the inner solar system in such a short time. The inherent unpredictability of cosmic events such as this highlights the importance of continuous observation and improved technology. It also serves as a reminder that even with our best efforts, space remains a realm full of surprises. We may never be able to predict every cosmic event, but with more advanced systems, we can prepare for the ones that come our way. The surprise of the 2025 comet surge begs the question: are there hidden patterns in cosmic events that we are simply not yet able to detect? While the laws of physics govern the behavior of celestial bodies, the sheer complexity and scale of the universe make it difficult to discern all the forces at play. Is the clustering of these 7 comets a rare coincidental alignment, or could it be part of a larger cosmic cycle that we have yet to fully understand? One possibility is that the appearance of multiple comets in 2025 could be part of a larger cycle of cosmic events. The solar system's motion through the galaxy, for example, could expose it to regions of space with higher densities of comets or interstellar objects. Similarly, gravitational interactions with nearby stars or the galactic tide may cause objects in the Oort cloud and Kuiper belt to be nudged toward the inner solar system at regular intervals. These ideas suggest that while individual events may seem random, they could be part of an underlying cosmic rhythm that we have not yet fully identified. The key to understanding cosmic unpredictability lies in improved data collection and analysis. By tracking the movement of objects across vast stretches of space and refining our models of cosmic dynamics, we may eventually be able to discern patterns that explain the seeming randomness of events like the surge of comets in 2025. As comets approach the Sun, they are heavily influenced by the solar wind, a continuous stream of charged particles emitted by the Sun's corona. This solar wind has a direct impact on comets, especially when they venture into the inner solar system. The intensity of the solar wind changes depending on the Sun's activity, which can, in turn, affect the behavior of comets and alter their orbits. When comets come close to the Sun, the solar wind interacts with the comet's icy nucleus, causing it to sublimate and release gases, dust, and other materials into space. This results in the formation of the comet's characteristic coma, the glowing halo around the nucleus, and its tail, which always points away from the Sun. The interaction between the solar wind and a comet's tail is a key aspect of the comet's appearance, but it also influences the comet's motion. During periods of heightened solar activity, such as solar flares and coronal mass ejections, CMEs, the solar wind becomes more intense. This increased solar activity can affect the trajectory of comets, particularly those that are close enough to the Sun to experience the full force of the solar wind. These interactions can cause comets to accelerate, shift in their orbits, or even break apart if the solar wind is strong enough. For the 7 comets of 2025, it's possible that heightened solar activity influenced their behavior. While none of the comets in question posed a direct threat to Earth, some of them exhibited unusual features, such as particularly long tails or bright comas. These anomalies could be the result of increased solar activity, which affected their movement and appearance as they made their way through the inner solar system. The Sun's activity could also explain why several comets arrived at roughly the same time. While the orbits of comets are typically governed by gravitational forces, the Sun's activity may have played a role in synchronizing their appearances. Comets that are in the outer reaches of the solar system can take hundreds or even thousands of years to complete their orbits. However, during periods of high solar activity, their orbits can be affected by the intense solar wind, causing them to arrive in the inner solar system during the same period. As the Sun goes through its solar cycles, the intensity of solar activity waxes and wanes, with peaks of increased activity occurring roughly every 11 years. The 7 comets of 2025 may have been influenced by this cyclical solar activity, which could have synchronized their journeys toward the inner solar system. If the solar wind had reached its peak activity around the time these comets were moving through the outer solar system, their paths may have been altered, causing them to converge near Earth and Mars. The Oort cloud and the Kuiper belt are 2 distant regions of the solar system that are often referred to as the reservoirs of comets. These regions are home to billions of icy bodies, many of which remain undisturbed in their orbits for millions of years. However, when external forces, whether from nearby stars, interstellar objects, or the Sun's gravitational influence, disturb these objects, they can be sent on trajectories that bring them into the inner solar system. The Oort cloud is a vast spherical region surrounding the solar system, extending from about 2,000 to 100,000 astronomical units (AU) from the Sun. It is believed to be the source of most long-period comets, which have highly elliptical orbits that bring them close to the Sun only once during their long journeys. The objects in the Oort cloud are made primarily of ice, dust, and other volatile compounds, and they are thought to be remnants of the early solar system. While the objects in the Oort cloud are generally stable, their orbits are not fixed. When nearby stars pass within a certain distance, or when other gravitational influences from the galaxy's tidal forces act upon them, objects in the Oort cloud can be perturbed and sent on new trajectories. These disturbances can result in comets being directed into the inner solar system, where they become visible to astronomers as they approach the Sun.
The surge of 7 comets in 2025 could be linked to a disturbance in the Oort cloud. Perhaps a passing star or an interstellar object, such as 3I Atlas, interacted with the Oort cloud, sending a cluster of comets on their way to the inner solar system. While the precise cause of this disturbance is still unknown, it is possible that the appearance of multiple comets in such a short time is the result of a galactic-scale event that affected the Oort cloud. The Kuiper belt, located just beyond the orbit of Neptune, is a region filled with icy bodies and dwarf planets. Unlike the Oort cloud, which contains long-period comets, the Kuiper belt is home to short-period comets, which have more stable, elliptical orbits that bring them into the inner solar system on a more regular basis. Many of the comets that arrive in the inner solar system on predictable cycles originate in the Kuiper belt. The gravitational influence of Neptune, in particular, can cause objects in the Kuiper belt to shift in their orbits, sending them toward the Sun. This could explain why some comets arrive near Earth and Mars in predictable patterns. The appearance of multiple comets from the Kuiper Belt in 2025 may have been influenced by a change in the gravitational dynamics of this region, potentially triggered by Neptune or other giant planets. The appearance of the 7 comets in 2025 has captured the imagination of the public and reignited interest in space science. Throughout history, comets have been seen as omens or mysterious visitors from the heavens, often inspiring awe, fear, and wonder. In modern times, comets are studied for the valuable scientific data they provide, but they still retain an air of mystery, representing an unknown part of the universe that humanity is only beginning to explore. The study of comets, interstellar objects, and the vast cosmos has always carried with it a sense of wonder. As we learn more about the origins of comets and the forces that shape the universe, we are reminded of our own place in the grand scheme of things. The arrival of the 7 comets in 2025, along with the recent discovery of 3I Atlas, forces us to confront the vastness of space and our relative insignificance in it. This reflection can lead to deeper philosophical questions. What is the nature of life and the universe? Are we alone in the cosmos, or are we just one of many civilizations in a galaxy teeming with life? How do cosmic events influence our understanding of time, space, and our own existence? While scientific discovery plays a critical role in advancing our knowledge of the universe, these discoveries also prompt existential questions. The study of comets, interstellar objects, and other cosmic phenomenon encourages humanity to think about our place in the cosmos and the broader implications of space exploration. As we continue to unravel the mysteries of the universe, we are not only answering scientific questions, but also exploring the deeper philosophical and existential questions that humanity has only beginning to explore. The discovery of the 7 comets and the ongoing study of interstellar objects are just the beginning of humanity's journey into the cosmos. While these events have raised new questions and posed new challenges, they also offer tremendous opportunities for scientific discovery and exploration. The study of comets, asteroids, and interstellar objects has the potential to reveal new insights into the origins of the solar system, the nature of the galaxy, and the possibility of life beyond Earth. As we continue to develop new technologies and advance our understanding of space, humanity is entering a new era of space exploration. The surge of comets in 2025, combined with the study of interstellar objects like 3I Atlas, has ignited a new sense of excitement and curiosity about the universe. Space agencies around the world are investing in missions to study distant planets, moons, and asteroids, while private companies are exploring the possibility of human space travel beyond the Moon and Mars. In the coming decades, humanity may embark on missions to other star systems, opening up a new chapter in our exploration of the universe. These missions, while still far off, will be informed by the knowledge gained from studying comets and interstellar objects. By learning how these objects travel across the galaxy, we will be better prepared for the challenges of interstellar travel. The future of space exploration holds immense potential, and the surge of comets in 2025 serves as a reminder of the vast, unpredictable nature of the cosmos. As we continue to study these objects and expand our understanding of space, humanity's destiny among the stars becomes ever more attainable. The arrival of 3I Atlas and the surge of 7 comets in 2025 marked an unprecedented moment in space exploration, highlighting the solar system's interaction with objects from beyond its borders. Prior to this event, the study of comets and asteroids primarily focused on bodies within our solar system. However, the discovery of interstellar objects like 3I Atlas forces astronomers to reconsider the boundaries of our solar system, shifting our focus from localized studies to an expanded understanding of the galaxy at large. Interstellar space, the vast expanse that separates star systems, has long been a subject of theoretical interest.
However, the passage of objects like 3I Atlas into the solar system has allowed scientists to study interstellar space directly. These objects, traveling from star systems millions of light-years away, carry with them critical data about the conditions and composition of their home systems. The study of 3I Atlas, for example, provides clues about its star system's formation, the composition of interstellar space, and the possibility of habitable conditions on planets around other stars.
For decades, our understanding of space was limited to the sun and the objects bound to it by its gravity. But with the confirmation that objects can travel between star systems, the notion that our solar system is isolated within its own bubble is no longer valid. Interstellar objects are not anomalies. They are part of a larger, galactic ecosystem that stretches across the universe, and our solar system is just one of many within this vast expanse. Objects like 3I Atlas are akin to time capsules, preserving the chemical signatures of their home star systems and the interstellar space they have traveled through. By studying the composition and trajectory of these objects, scientists can gain insight into the environmental conditions of other star systems, offering a glimpse into the broader processes that govern star and planet formation. This new knowledge will allow astronomers to refine their models of the formation of the solar system and other star systems, potentially leading to breakthroughs in our understanding of the galaxy's evolution. The data we gather from interstellar objects could also inform the search for exoplanets, planets that orbit stars outside our solar system. If the material found in 3I Atlas and other interstellar objects is similar to what we find in the planetary systems we observe, it could indicate that planets with similar chemical compositions are more common than we once thought. This would have profound implications for the search for extraterrestrial life, as it would suggest that the ingredients for life may be present on a larger scale across the galaxy. The study of comets and interstellar objects like 3I Atlas raises exciting possibilities for the search for extraterrestrial life. Comets are known to contain a wide variety of organic compounds, including amino acids and other molecules essential for life as we know it. The presence of these compounds in 3I Atlas and other interstellar objects suggests that life's building blocks may be more widespread in the galaxy than previously thought. One of the most intriguing theories that has emerged from the study of comets is the idea of panspermia, the notion that life, or at least the building blocks of life, could spread across the galaxy via comets, asteroids, and other celestial bodies. This idea posits that life may have originated on one planet and then spread to others through the impact of cosmic objects. While the theory remains speculative, the discovery of organic molecules in comets lends support to the idea that the materials necessary for life could be traveling between stars. The chemical composition of 3I Atlas suggests that it originated in a star system very different from our own, yet it contains organic compounds that are essential to life on Earth. Could this object, and others like it, be carrying the seeds of life to distant star systems? If so, this would dramatically change our understanding of life in the universe, suggesting that life is not limited to Earth, but could be more common than we ever imagined. The discovery of organic molecules in interstellar objects also has profound implications for the search for life on exoplanets. As we discover more planets orbiting stars in the habitable zone, the region around a star where liquid water could exist, astronomers are also looking for
signs of life. The presence of organic compounds in comets and interstellar objects suggests that these molecules may be more common across the galaxy than previously thought. This raises the possibility that life could exist on exoplanets that are located light years away from Earth. By studying interstellar objects like 3I Atlas, we can gain a better understanding of how the ingredients for life travel across the galaxy and how they might contribute to the development of life on other planets. If life's building blocks are being transported between star systems, the chances of finding life elsewhere in the galaxy increase significantly. This discovery has the potential to change the course of the search for extraterrestrial life, as it suggests that the universe may be teeming with the raw materials necessary for life. The surge of 7 comets in 2025 serves as a reminder of the vastness of space and our place within it. While Earth may seem like the center of the universe to us, the reality is that our solar system is just one of billions of star systems in the Milky Way galaxy, which is itself one of billions of galaxies in the observable universe. The appearance of multiple comets, some of which traveled from distant star systems, underscores the vast distances and scale of the cosmos. In the context of the solar system, the appearance of 7 comets in 2025 seems like a rare event. However, in the broader scope of the galaxy, these objects are just a small fraction of the cosmic traffic that passes through the solar system. The Oort cloud and Kuiper belt, regions that contain countless icy bodies, are constantly sending comets and asteroids into the inner solar system. In fact, the solar system is constantly bombarded by objects from beyond its borders, many of which go unnoticed until they approach the sun. This constant influx of cosmic objects is a testament to the dynamic nature of the solar system. It is not a static, isolated system, but part of a much larger cosmic web. As our solar system moves through the galaxy, we encounter objects from other star systems, each with its own unique properties and origins. The study of these objects not only helps us understand the solar system, but also provides insights into the processes that govern the formation and evolution of stars and planets. Our solar system exists within a vast galaxy filled with billions of stars, each with its own planetary system. The interactions between these stars, their gravitational pull, and the cosmic material that exists between them create a dynamic environment. Objects like 3I Atlas and the 7 comets of 2025 are a small part of the larger galactic ecosystem, moving through space and interacting with one another in ways that we are only beginning to understand. This new understanding of the solar system's place in the galaxy is changing how we think about the universe. The solar system is not isolated, but part of a complex and interconnected
network of stars, planets, and cosmic bodies. The appearance of interstellar objects like 3I Atlas and the 7 comets highlights just how interconnected the universe truly is, and it challenges our previous understanding of the solar system as a static, isolated entity. The surge of 7 comets in 2025, combined with the passage of interstellar objects like 3I Atlas, has underscored the need for increased global collaboration in space science and exploration. The complexities of tracking and studying these objects, many of which come from distant star systems, require the combined efforts of space agencies, astronomers, and researchers from around the world. The study of comets, asteroids, and interstellar objects cannot be done by any one country or agency alone. Given the global nature of these objects and their potential impact on Earth, international cooperation is essential. Space agencies like NASA, the European Space Agency, ESA, China's CNSA, and others must work together to develop a unified approach to tracking and studying cosmic phenomena. This global collaboration is crucial for several reasons. First, it allows for the pooling of resources and expertise, which increases the chances of detecting and tracking objects before they enter the inner solar system. Second, it ensures that data is shared across countries, allowing for more comprehensive studies of cosmic objects. Third, international cooperation strengthens planetary defense efforts by enabling a coordinated response to potential threats from space. In addition to space agencies, private companies like SpaceX, Blue Origin, and others are playing an increasingly important role in space exploration.
These companies are driving innovation and expanding the reach of space exploration by developing new technologies for spacecraft, propulsion, and space-based observation. As the commercial space industry continues to grow, it will be essential for governments and private companies to collaborate in order to tackle the challenges posed by cosmic events. The involvement of private space companies in space exploration is a positive development for the study of cosmic events, like the surge of comets in 2025. These companies bring new ideas, technology, and funding to the table, helping to accelerate the pace of discovery and expand our ability to observe and explore space. The potential threat posed by comets and other cosmic objects has long been a subject of scientific discussion. While the risk of a catastrophic impact remains low, the consequences of such an event could be devastating. The study of the 7 comets in 2025, along with the arrival of interstellar objects like 3I Atlas, has emphasized the importance of improving planetary defense systems and preparing for future cosmic collisions.
Planetary defense involves the detection, tracking, and mitigation of potentially hazardous objects, PHOs, like asteroids and comets that could collide with Earth. Currently, space agencies around the world are focused on identifying these objects early in their approach and developing strategies to prevent an impact. NASA's Planetary Defense Coordination Office has been at the forefront of this effort, working to detect and track near-Earth objects. While the PDCO has made significant progress in monitoring these objects, the passage of interstellar objects like 3I Atlas has highlighted the need for planetary defense systems that can also address objects from beyond our solar system. These objects move much faster and are more difficult to track, making them a unique challenge for planetary defense. The development of new technologies to prevent cosmic collisions is a priority for space agencies and researchers. One possible approach is the use of kinetic impactors, spacecraft designed to collide with an object in space and change its trajectory. While this method is effective for deflecting objects within the solar system, the high velocities of interstellar objects make them much harder to intercept. Another potential method is nuclear deflection, where a nuclear device is detonated near the object to alter its path. While still theoretical, this approach has gained attention as a way to deal with larger objects that cannot be deflected using traditional methods. However, these strategies are still in the early stages of development, and much more research is needed before they can be used in real-world scenarios. As the threat of cosmic impacts becomes more apparent, international collaboration will be key to developing effective planetary defense systems. Governments, space agencies, and private companies must work together to pool resources and expertise in order to detect, track, and mitigate the risks posed by comets, asteroids, and interstellar objects. By sharing data and coordinating efforts, the global community can work together to protect Earth from potential cosmic threats. The appearance of 7 comets in 2025 serves as a wake-up call, reminding us that while the likelihood of a collision may be low, the consequences of such an event could be catastrophic. The need for planetary defense has never been more urgent. While the surge of comets and the study of interstellar objects like 3I Atlas has expanded our understanding of the solar system, it also raises a deeper question: what lies beyond the solar system? The solar system itself is just a tiny part of the vast Milky Way galaxy, which is one of billions of galaxies in the observable universe. What do we know about the regions of space beyond our solar system, and how can we explore them?
The discovery of exoplanets, planets that orbit stars outside our solar system, has been one of the most exciting breakthroughs in astronomy. Thousands of exoplanets have been discovered in recent years, many of which reside in the habitable zone of their stars. The arrival of 7 comets in 2025 raises intriguing questions about the potential for life beyond Earth. As astronomers analyze the chemical composition of these comets, they find traces of organic molecules that are essential to life as we know it. The presence of these compounds on comets that originate from the farthest reaches of the solar system or from interstellar space suggests that life's building blocks may be more widespread in the galaxy than we ever imagined. Could these comets hold the keys to understanding the origins of life in the universe? Comets are often referred to as the dirty snowballs of the solar system, composed mostly of water, ice, dust, and various gases. But they also contain organic molecules, molecules that contain carbon, hydrogen, nitrogen, oxygen, and other elements that are essential to life. The discovery of these compounds is not new. Scientists have known for decades that comets could contain organic material. However, the 2025 surge of comets, along with the presence of complex organic molecules like cyanogen and amino acids, brings new attention to the potential role of comets in seeding life elsewhere in the galaxy. The discovery of amino acids in comets is of particular interest, as these molecules are the building blocks of proteins which are essential for life. The fact that amino acids have been found in comets suggests that the basic components for life might be more common than previously thought. This has led scientists to consider the possibility that life could be widespread in the galaxy, not just on Earth, but on other planets or moons that harbor the right conditions for life to develop. The theory of panspermia posits that life, or at least its building blocks, could spread across the galaxy on comets, asteroids, and other celestial objects. This theory proposes that life might have originated on one planet, only to be transported to others through impacts by comets or asteroids. If this theory is true, the appearance of complex organic molecules in the comets of 2025 could be a sign that life's building blocks are being transported across the galaxy, potentially seeding life on other planets and moons. The theory of panspermia posits that life, or at least its building blocks, could spread across the galaxy on comets, asteroids, and other celestial objects. This theory proposes that life might have originated on one planet, only to be transported to others through impacts by comets or asteroids. If this theory is true, the appearance of complex organic molecules in the comets of 2025 could be a sign that life's building blocks are being transported across the galaxy, potentially seeding life on other planets and moons. If life's building blocks are indeed spread across space via cosmic traffic, then the chances of finding life elsewhere in the universe are significantly higher than we once thought. In fact, the discovery of complex organic compounds in 3I Atlas and the 7 comets reinforces the idea that life, or the ingredients necessary for life, may not be confined to Earth. As we continue to study these interstellar visitors, the prospect of finding life beyond our planet becomes more promising.
The surge of comets in 2025, alongside the study of interstellar objects like 3I Atlas, has provided scientists with a unique opportunity to explore the processes that shape our solar system and the broader galaxy. Comets are relics of the early solar system, and their chemical compositions offer valuable insights into the materials that were present during the formation of the solar system. By studying these objects, we can gain a deeper understanding of how planets, moons, and other celestial bodies form, as well as how the solar system fits into the broader evolution of the galaxy. Comets are often seen as the leftovers of the solar system's formation, made up of materials that were too cold to form planets or moons. During the early stages of the solar system's formation, the sun's heat prevented solid bodies from forming close to the star. However, in the outer regions, beyond the frost line, icy bodies began to accumulate. These bodies, comets, asteroids, and other small objects, remained largely unchanged, preserving a snapshot of the conditions that existed when the solar system was still young.
The study of comets from the outer reaches of the solar system, as well as interstellar objects like 3I Atlas, can help us understand the types of materials that were present during the early solar system's formation. By analyzing the chemical composition of these objects, scientists can gain a better understanding of the building blocks of the solar system and how the materials that formed planets, moons, and asteroids were distributed throughout the galaxy. Interstellar objects like 3I Atlas provide another key piece of the puzzle. These objects, which have traveled across vast distances between star systems, carry with them information about the conditions in other parts of the galaxy. The fact that 3I Atlas contains organic molecules suggests that similar processes may be at play in other star systems, and that the ingredients for life could be more common than we once thought. By studying these objects, astronomers can refine their models of how star systems form and evolve, and how materials are exchanged between different regions of the galaxy. 3I Atlas is a reminder that our solar system is not an isolated system, but part of a much larger galactic network. The objects that pass through our solar system, whether they come from the Oort cloud, the Kuiper belt, or even interstellar space, offer glimpses into the forces and processes that shape the universe on a cosmic scale. By studying these objects, we gain not only a better understanding of our own solar system, but also insight into the broader workings of the galaxy. As the study of comets, asteroids, and interstellar objects progresses, it becomes increasingly clear that the future of space exploration lies in the development of advanced technologies. The 7 comets of 2025 and the passage of 3I Atlas have provided scientists with unprecedented opportunities to learn about the solar system and the galaxy. But these discoveries are only possible because of the technology that allows us to observe and track these objects. In order to continue pushing the boundaries of space exploration, we must invest in cutting-edge
technologies that will enable us to study these objects in even greater detail and expand our ability to explore the cosmos. One of the key tools that has allowed us to study objects like 3I Atlas is the Space Telescope. These telescopes, which operate outside of Earth's atmosphere, can observe the cosmos with unparalleled clarity. The James Webb Space Telescope, JWST, set to launch in the near future, is poised to revolutionize the way we study distant objects. With its ability to observe infrared light, JWST will be able to peer through cosmic dust and gas, allowing us to study the formation of stars, galaxies, and planetary systems in unprecedented detail. The JWST will be particularly valuable in the study of interstellar objects like 3I Atlas. By observing these objects at different wavelengths of light, scientists can gain valuable information about their chemical composition, trajectory, and origins. In addition, space telescopes like JWST will play a crucial role in the search for exoplanets and the study of potentially habitable worlds. These advancements in space observation will help to shape our understanding of the universe and guide the next generation of space exploration missions. In addition to space telescopes, the development of robotic spacecraft is another key area of innovation in space exploration. Robotic probes, like NASA's Voyager missions, have already traveled far beyond the solar system, collecting valuable data about the outer reaches of space. However, future missions will need to go even farther, into the unknown reaches of interstellar space. The study of interstellar objects like 3I Atlas will require the development of spacecraft that can travel at much higher speeds than current technology allows. Concepts like solar sails, which use the pressure of sunlight to propel a spacecraft, and nuclear-powered propulsion systems, which could achieve speeds far beyond what is currently possible, are already being explored as potential methods for interstellar travel. These technologies are still in their infancy, but they represent the future of space exploration. While the idea of interstellar travel may seem like the stuff of science fiction, recent advancements in space exploration have made it more plausible than ever before. The passage of interstellar objects like 3I Atlas has brought the concept of interstellar exploration into sharper focus, demonstrating that objects can travel vast distances between stars. But what would it take for humanity to send a probe or even a crewed mission beyond the solar system? The dream of reaching other stars is no longer a distant fantasy, but a real possibility for the future. The first step toward interstellar exploration will likely come in the form of robotic probes. These probes could be designed to travel to nearby star systems such as Proxima Centauri, the closest star to Earth. Although this mission would take many years, if not centuries, to complete, it would mark the beginning of humanity's journey beyond the solar system. Interstellar probes could be propelled by a variety of technologies, including solar sails, which use the pressure of sunlight to propel a spacecraft, or nuclear propulsion, which offers higher speeds and greater efficiency than traditional chemical rockets. These technologies are still in the experimental stages, but the study of objects like 3I Atlas will help guide the development of spacecraft that can withstand the harsh conditions of interstellar space. Interstellar travel presents a number of significant challenges. The distances between stars are so vast that even the fastest spacecraft we have today would take tens of thousands of years to reach the nearest star systems. In addition, interstellar space is filled with cosmic radiation, high-energy particles, and other hazards that could pose a serious threat to human travelers. To overcome these challenges, we will need to develop new propulsion systems, advanced shielding technologies, and sustainable life support systems that can support long-duration missions. Despite these challenges, the potential rewards of interstellar exploration are immense. By studying other star systems, we could learn more about the formation of planets and moons, the possibility of extraterrestrial life, and the future of our own solar system. Interstellar travel offers the promise of unlocking the deepest mysteries of the universe, and the discoveries made along the way will shape humanity's understanding of its place in the cosmos. The surge of comets in 2025 and the passage of interstellar objects like 3I Atlas have not only advanced our scientific understanding of space, but have also prompted a deeper philosophical reflection on humanity's place in the universe. Throughout history, cosmic events have been a source of wonder, fear, and inspiration, and the discoveries made in recent years have only intensified our fascination with the cosmos. One of the key philosophical questions raised by the study of interstellar objects and cosmic events is the nature of time and space itself. The vast distances between stars, the ages of galaxies, and the relative insignificance of human existence in the context of cosmic time all force us to confront the limits of our understanding. These cosmic events remind us that we are part of something much larger and older than ourselves, and they challenge our conventional notions of time, space, and our place in the universe. As we explore space, we are forced to rethink our understanding of time. The concept of time in space is different from what we experience on Earth. The distances between stars and the vastness of the galaxy mean that events unfold over timescales that are difficult to comprehend. A comet may travel for millions of years before reaching the inner solar system, and a journey to another star system could take centuries or even millennia. The discovery of life's building blocks in comets and the possibility of life beyond Earth raises profound existential questions about humanity's place in the universe. Are we alone in the cosmos, or is life more common than we realize? The possibility that life may exist elsewhere in the galaxy forces us to confront the question of what it means to be human. How do we fit into the larger tapestry of the universe? And what is our role in the grand cosmic story? These questions are at the heart of humanity's search for meaning in the cosmos. As we continue to explore space and uncover the mysteries of the universe, we are not only advancing our scientific knowledge, but also exploring the deeper philosophical and existential questions that define our existence. The discoveries made from the study of comets and interstellar objects will shape the future of space exploration, but they will also shape the way we think about ourselves and our place in the universe. The solar system, once thought to be an isolated and self-contained system of planets orbiting a single star, is now understood to be just a small part of a much larger galactic ecosystem. The surge of 7 comets in 2025, along with the passage of interstellar objects like 3I Atlas, has brought into sharp focus the interconnectedness of the solar system with the broader galaxy and beyond. As we continue to explore space, it becomes increasingly clear that our understanding of the solar system's origins and evolution must account for its interactions with other stars, star systems, and even the galactic medium. Our solar system is not stationary. It is in constant motion, orbiting the center of the Milky Way galaxy. This movement takes the solar system through different regions of space, each with varying levels of gravitational and cosmic influence. The solar system's current trajectory, traveling through the low-density gas, has shielded us somewhat from the gravitational effects of nearby stars and the galactic tide. However, as the solar system continues its orbit, it will eventually pass through denser regions of space that could have a significant impact on the motion of objects within the solar system, including comets, asteroids, and even interstellar objects. This galactic motion may explain periodic surges in cosmic traffic, such as the appearance of multiple comets in a short time span. The passage of the solar system through denser regions of the galaxy could send objects from the Oort cloud, Kuiper belt, or even interstellar space on trajectories that bring them into the inner solar system. While these events are unpredictable, they are part of the larger galactic cycle that governs the movement of our solar system through the galaxy. The solar system is part of a vast and interconnected network of stars, planets, and cosmic bodies. Each star system in the galaxy has its own gravitational influence on surrounding objects, and these influences can affect the movement of comets and asteroids. Additionally, the galactic tide, a force caused by the collective gravitational pull of all the stars in the Milky Way, can subtly alter the orbits of objects in the solar system, including those in the Oort cloud and Kuiper belt.
The arrival of interstellar objects like 3I Atlas highlights how the solar system is not a standalone entity, but rather part of a dynamic and ever-changing galactic system. Objects from outside the solar system can pass through our neighborhood, carrying with them information about other star systems and their conditions. This interconnectedness is a reminder that our solar system is part of something much larger, and that the forces shaping our solar system's evolution are beyond our control. The study of interstellar objects, such as 3I Atlas, and their interactions with the solar system provides valuable insight into the broader dynamics of the galaxy and the cosmic web of interactions that govern the universe. While the Sun is the central force of our solar system, providing light, heat, and energy to the planets, its influence extends far beyond just the inner planets. The Sun's gravitational pull keeps the solar system together, but it also affects the movement of comets, asteroids, and other cosmic objects. Its solar wind, a constant stream of charged particles, also plays a crucial role in shaping the behavior of objects that venture into the inner solar system. Comets are primarily composed of ice and dust, and as they approach the Sun, the heat causes their ice to sublimate, creating a glowing coma, the cloud of gas and dust surrounding the nucleus, and a tail that points away from the Sun. This tail, visible from Earth, is a result of the solar wind pushing the comet's gases and dust outward. The solar wind itself is made up of charged particles, electrons and protons, that exert pressure on the gas surrounding a comet. This interaction is a key part of the process that gives comets their characteristic appearance. The strength of the solar wind changes over the course of the Sun's solar cycle, which lasts approximately 11 years.
During periods of heightened solar activity, such as solar maximum, the solar wind is stronger, and the effects on comets can be more pronounced. The increased solar activity can cause comets to brighten, change the shape of their tails, or even alter their orbit slightly as they are pushed along by the solar wind. This variability in solar activity is something astronomers must consider when studying comets, especially those that travel from the outer reaches of the solar system, or even from other star systems, as it can significantly influence their behavior as they enter the solar system. In addition to the solar wind, the Sun is also capable of producing more intense bursts of energy known as solar flares and coronal mass ejections. These events release large amounts of energy and charged particles into space, which can have significant effects on objects in the solar system, including comets. A solar flare, or CME, can cause dramatic changes in a comet's tail, causing it to brighten or shift in direction, and it could potentially alter the comet's orbit if the force is strong enough. For the 7 comets that arrived in 2025, heightened solar activity during that period may have influenced their behavior as they approach the Sun. The Sun's activity is cyclical, with periods of high solar activity followed by periods of relative calm. Understanding the Sun's behavior is
Stars can disturb the orbits of objects in the Oort cloud, sending them on paths that bring them into the inner solar system. Some scientists believe that the surge of comets in 2025 could be linked to such a galactic disturbance. A nearby star, or even a rogue planet, may have passed close enough to the Oort cloud to disturb the orbits of several comets, sending them toward the Sun. This idea supports the notion that cosmic traffic is not random, but part of a larger galactic cycle that causes periodic bursts of cometary activity. The solar system's motion through the galaxy is also influenced by the galactic tide, a force caused by the combined gravitational pull of all the stars in the Milky Way. The galactic tide can affect the orbits of objects in the Oort cloud, causing them to be nudged toward the Sun over time. The solar system's position in the galaxy and the gravitational forces it encounters as it moves through space can have a profound impact on the frequency and intensity of cometary surges. The study of these galactic forces is critical for understanding the larger cosmic dynamics that affect the solar system. By observing how objects from the Oort cloud and Kuiper belt are influenced by galactic forces, astronomers can begin to identify patterns in the movement of comets and other cosmic objects. This understanding can help predict future cometary surges, giving scientists more time to study these objects and prepare for any potential risks they might pose to Earth. As humanity embarks on future space missions, one of the biggest challenges we face is the threat of cosmic radiation. This high-energy radiation comes from sources outside the solar system, including supernovae and other galactic phenomena. While the Earth's atmosphere and magnetic field offer protection from cosmic radiation, astronauts traveling beyond the Earth's protective shield will be exposed to much higher levels of radiation. Cosmic radiation can have serious health consequences for astronauts, including increased risk of cancer, radiation sickness, and long-term genetic damage. For missions to the Moon, Mars, and beyond, space agencies will need to develop shielding technologies to protect astronauts from this radiation. Cosmic radiation is also a threat to spacecraft electronics and equipment, which can be damaged or malfunction as a result of exposure to high-energy particles. To mitigate these risks, space agencies are researching new materials and technologies that can shield astronauts and spacecraft from cosmic radiation. These include radiation-resistant spacecraft hulls, advanced spacesuits, and protective shelters that astronauts can use during long-duration space missions. As the study of cosmic radiation advances, we will better understand how to protect human life in space and ensure the safety of future missions to Mars, the outer planets, and beyond. Stars can disturb the orbits of objects in the Oort cloud, sending them on paths that bring them into the inner solar system.
Some scientists believe that the surge of comets in 2025 could be linked to such a galactic disturbance. A nearby star, or even a rogue planet, may have passed close enough to the Oort cloud to disturb the orbits of several comets, sending them toward the Sun. This idea supports the notion that cosmic traffic is not random, but part of a larger galactic cycle that causes periodic bursts of cometary activity. The solar system's motion through the galaxy is also influenced by the galactic tide, a force caused by the combined gravitational pull of all the stars in the Milky Way. The galactic tide can affect the orbits of objects in the Oort cloud, causing them to be nudged toward the Sun over time. The solar system's position in the galaxy and the gravitational forces it encounters as it moves through space can have a profound impact on the frequency and intensity of cometary surges. The study of these galactic forces is critical for understanding the larger cosmic dynamics that affect the solar system. By observing how objects from the Oort cloud and Kuiper belt are influenced by galactic forces, astronomers can begin to identify patterns in the movement of comets and other cosmic objects. This understanding can help predict future cometary surges, giving scientists more time to study these objects and prepare for any potential risks they might pose to Earth. As humanity embarks on future space missions, one of the biggest challenges we face is the threat of cosmic radiation. This high-energy radiation comes from sources outside the solar system, including supernovae and other galactic phenomena. While the Earth's atmosphere and magnetic field offer protection from cosmic radiation, astronauts traveling beyond the Earth's protective shield will be exposed to much higher levels of radiation. Cosmic radiation can have serious health consequences for astronauts, including increased risk of cancer, radiation sickness, and long-term genetic damage. For missions to the Moon, Mars, and beyond, space agencies will need to develop shielding technologies to protect astronauts from this radiation. Cosmic radiation is also a threat to spacecraft electronics and equipment, which can be damaged or malfunction as a result of exposure to high-energy particles. To mitigate these risks, space agencies are researching new materials and technologies that can shield astronauts and spacecraft from cosmic radiation. These include radiation-resistant spacecraft hulls, advanced spacesuits, and protective shelters that astronauts can use during long-duration space missions. As the study of cosmic radiation advances, we will better understand how to protect human life in space and ensure the safety of future missions to Mars, the outer planets, and beyond.
The passage of interstellar objects like 3I Atlas also highlights the potential dangers of cosmic radiation for spacecraft. Interstellar objects travel through space at high velocities, and their interaction with the solar wind can produce radiation that could damage spacecraft. This makes it even more critical to develop robust shielding technologies for long-duration missions, especially those aimed at interstellar exploration. As we look toward future missions to explore the stars, cosmic radiation will remain one of the most significant challenges. However, with continued research and technological innovation, we can develop the tools needed to protect astronauts and spacecraft from these dangers and ensure the success of future space missions. The study of comets, asteroids, and interstellar objects like 3I Atlas has raised important questions about planetary defense. While the likelihood of an asteroid or comet impact is low, the potential consequences of such an event are catastrophic. As a result, space agencies and scientists around the world have been working to develop systems that can detect, track, and mitigate the risks posed by cosmic threats. Currently, space agencies like NASA and the European Space Agency, ESA, monitor the skies for near-Earth objects, NEOs, including asteroids and comets. These objects are tracked using ground-based telescopes, space-based observatories, and radar systems, allowing scientists to determine their size, composition, and trajectory.
Early detection is crucial, as it provides time to develop strategies to deflect or mitigate a potential impact. While these detection systems are effective for tracking objects that are relatively close to Earth, interstellar objects like 3I Atlas present a unique challenge. These objects arrive from outside the solar system and often travel at much higher speeds than typical NEOs, making them harder to detect and track. As a result, planetary defense systems must be adapted to handle the unpredictability of interstellar objects and the increased speed at which they travel. One of the most promising planetary defense strategies is the use of kinetic impactors, spacecraft designed to collide with an incoming object to change its trajectory. This method has been successfully tested in simulations and could be used to divert an asteroid or comet away from Earth. However, the high velocities of interstellar objects present a significant challenge for kinetic impactors. These objects would require much larger, faster spacecraft to intercept and redirect them. Another potential solution is the use of nuclear deflection, which involves detonating a nuclear device near the incoming object to alter its course. While this method is still in the early stages of development, it has garnered interest as a way to deal with larger, more threatening objects. The use of nuclear weapons in space would raise significant political and ethical concerns, but the potential benefits of such a system cannot be ignored.
Planetary defense is a global challenge, and addressing the threat of cosmic objects requires international collaboration. Space agencies, governments, and private companies around the world must work together to monitor cosmic threats, share data, and develop strategies for mitigating risks. The appearance of 7 comets in 2025, combined with the potential for interstellar visitors like 3I Atlas, underscores the need for a coordinated global effort to protect Earth from cosmic threats. The discovery of 3I Atlas and other interstellar objects has rekindled the dream of interstellar exploration. While we are still many decades away from sending humans to other star systems, the study of interstellar objects has provided valuable data on how objects from other star systems behave as they travel through the galaxy. Interstellar probes are one step closer to reality. While current technology limits the speed and range of spacecraft, concepts like solar sails, lightweight, radiation-propelled craft, could potentially carry probes to nearby star systems within a few decades. These probes could be sent to study the environments of distant stars, planets, and moons, providing us with the first direct data on the conditions of other star systems. In addition to solar sails, nuclear-powered spacecraft are being explored as a potential means for faster interstellar travel. The technology to send probes to the stars may still be in its infancy, but the data we are gathering from objects like 3I Atlas is already laying the groundwork for future interstellar missions. While the dream of interstellar travel is exciting, the practical challenges are immense. The distances between stars are so vast that even the fastest spacecraft we currently have would take thousands of years to reach the nearest star. New propulsion systems, such as nuclear fusion or antimatter engines, will be necessary for humanity to send probes or crewed missions to other star systems. But the potential rewards of interstellar exploration are vast. By studying other star systems, we could learn more about the formation of planets, the potential for life, and the history of the galaxy itself. The discoveries made through interstellar exploration will not only help us understand the universe better, but also inspire future generations to push the boundaries of space travel. The surge of comets in 2025, combined with the passage of interstellar objects like 3I Atlas, has forced humanity to reevaluate its position in the cosmos. For centuries, we believed that Earth was the center of the universe, and our understanding of the cosmos was confined to our own solar system.
However, the discoveries of interstellar objects and the increasing evidence of the vastness and complexity of the universe have dramatically changed that perspective. Historically, humanity viewed Earth as the center of the universe. From ancient civilizations to the early days of modern astronomy, the belief in Earth's centrality was not just scientific, but also philosophical and religious. As our technological capabilities expanded, however, and our ability to explore space grew, we began to realize that Earth is just one of billions of planets orbiting a single star in an unremarkable corner of a vast galaxy. The passage of 3I Atlas through the solar system, along with the realization that interstellar objects can travel across vast distances between stars, has made it clear that our solar system is not isolated. Rather, it is part of a larger, interconnected cosmic system. The fact that interstellar objects can move freely between star systems has shifted our thinking about the solar system's place in the galaxy, and even the galaxy's place in the broader universe. The implications of this shift in perspective are profound. As we come to understand the dynamic, interconnected nature of the galaxy, we also realize how little we know about the broader universe and the forces that shape it. This humbling realization challenges us to rethink our assumptions about the origins of life, the nature of existence, and our place in the cosmos. The discovery of organic molecules in comets and interstellar objects has reignited the long-standing question, are we alone in the universe? For centuries, humanity has wondered whether other forms of life exist beyond Earth. The detection of complex organic compounds in objects from distant star systems suggests that the building blocks of life may be common throughout the galaxy. This discovery not only increases the likelihood of life existing elsewhere, but also raises deeper philosophical questions about the nature of life itself. If life can spread across the galaxy through objects like comets, it suggests that life could exist in many places, on exoplanets orbiting distant stars, or on moons in other star systems. The possibility that life is not confined to Earth challenges the traditional view of human exceptionalism and invites us to consider the potential for intelligent life elsewhere in the universe. This growing understanding of life's potential ubiquity changes how we view our role in the cosmos. If life exists elsewhere, what does that mean for our sense of purpose and our place in the grand scheme of things? The quest for answers to these questions will shape our exploration of space for generations to come. As humanity continues to study interstellar objects like 3I Atlas, the search for extraterrestrial intelligence, SETI, has entered a new phase. SETI has long been focused on detecting signals from advanced civilizations, particularly those transmitted via radio waves or other forms of electromagnetic radiation. However, the discovery of interstellar objects raises new questions.
A calm and interesting voice, reading about the nature of extraterrestrial life. Could advanced civilizations be using methods of communication or travel that we have not yet imagined? The Fermi paradox, named after the famous physicist who famously asked, "Where is everybody?" poses the question of why, given the vastness of the universe, we have not yet detected any signs of extraterrestrial civilizations. If intelligent life is so common, why haven't we made contact? The discovery of interstellar objects like 3I Atlas could provide new insights into this paradox. These objects, which travel across the galaxy at high speeds, suggest that it is possible for matter to move between star systems in ways that we had previously underestimated. Could it be that extraterrestrial civilizations have developed technologies that allow them to travel or communicate across vast distances? Could they be sending probes, like 3I Atlas, into other star systems? While we have not yet discovered direct evidence of extraterrestrial intelligence, the study of interstellar objects opens up new possibilities for understanding how civilizations might communicate or explore the galaxy. Perhaps we are not looking in the right way, or using the right tools to detect them.
The arrival of 3I Atlas also highlights the potential for future interstellar probes sent by other civilizations. If an advanced civilization could send objects across the galaxy, it may be possible for us to do the same one day. These objects could be both messages and scientific probes sent to explore other star systems, providing valuable data about the conditions of distant planets and the potential for life. The discovery of interstellar objects suggests that the search for extraterrestrial life may need to expand beyond just looking for radio signals. Instead, we might consider the possibility that extraterrestrial civilizations are sending physical objects, probes, scientific instruments, or even artificial artifacts across the galaxy. This shift in thinking could lead to a more comprehensive approach to SETI, one that includes not only the search for signals, but also the study of interstellar objects that might contain messages or scientific data from distant civilizations. This approach would require the development of new technologies and techniques to detect and study objects like 3I Atlas, as well as new methods for interpreting their potential meaning. The study of these objects may provide the key to unlocking the mysteries of interstellar intelligence and answering the question that has fascinated humanity for centuries: are we alone in the universe? As humanity sets its sights on exploring the stars, the challenge of long-duration space missions becomes increasingly relevant. The study of comets, particularly those that originate in the outer reaches of the solar system or beyond, provides valuable lessons for future interstellar travel.
These objects have traveled for millions of years across vast distances, surviving the harsh conditions of space and the cosmic radiation that permeates the galaxy. Space is a hostile environment. Cosmic radiation, extreme temperatures, and the vacuum of space present significant challenges for both human and robotic missions. As we look toward future interstellar missions, we must consider how to protect astronauts and spacecraft from these dangers. Comets, which are made up of ice and dust, provide a natural laboratory for studying how materials and spacecraft might fare in deep space. By studying the composition of comets and how they react to solar radiation, we can gain insights into how to build spacecraft that can withstand the challenges of long-duration missions. Additionally, the long journey of comets, often traveling millions of years before reaching the inner solar system, can inform our understanding of the timescales involved in interstellar travel. Interstellar probes will need to be designed for longevity and durability, capable of operating in the harsh environment of space for extended periods. By studying how comets survive over long periods, scientists can develop more robust spacecraft and technologies that will ensure the success of future missions to other stars. The Oort cloud and Kuiper belt, the two main reservoirs of comets, represent the outermost regions of the solar system. These distant regions are home to objects that are ancient and unchanged, providing scientists with a glimpse into the early history of the solar system. Similarly, studying the behavior of objects in these regions can offer insights into the conditions of deep space and the challenges of exploring distant star systems. As we plan for future interstellar missions, we can look to the behavior of comets and other objects from the outer solar system for guidance. These objects, some of which have traveled for billions of years, provide clues to the durability and resilience required for long-duration space travel. Understanding how comets survive the journey through the solar system and how they interact with the sun's radiation will help inform the design of spacecraft capable of surviving the harsh conditions of interstellar space. Artificial intelligence, AI, is poised to play a crucial role in the future of space exploration. As space agencies prepare for interstellar missions and long-duration space travel, AI will be essential in managing the complex tasks of navigating and operating spacecraft in the vast expanse of space. The study of comets, asteroids, and interstellar objects like 3I Atlas requires the ability to process vast amounts of data and make real-time decisions. This is where AI becomes invaluable. Space missions, particularly those that involve interstellar travel or long-duration space exploration, generate enormous amounts of data. From tracking the position of spacecraft to analyzing the composition of distant objects, the volume of information can be overwhelming. AI is uniquely suited to handle this task. By using machine learning algorithms, AI can analyze vast datasets, identify patterns, and make decisions based on real-time data. This capability is essential for future space missions, as it will allow spacecraft to autonomously navigate, process data, and even make decisions about how to adjust their trajectory or operations based on unexpected circumstances. In the case of interstellar exploration, AI could be used to monitor the spacecraft's systems, ensure that it stays on course, and detect any anomalies or problems before they become critical. For example, AI could help detect and analyze cosmic radiation, meteor impacts, or even gravitational influences from nearby stars that might affect the spacecraft's trajectory. This would allow mission controllers on Earth to receive real-time updates and make informed decisions about how to respond to any issues that arise during the mission. The future of space exploration will require spacecraft that are capable of operating autonomously for long periods of time. Interstellar missions will take decades or even centuries, and relying on human intervention from Earth will be impractical. AI will be essential in ensuring that spacecraft are capable of performing their tasks independently, managing their own systems, and maintaining communications with Earth. AI-powered spacecraft could be designed to adapt to changing conditions, learn from past experiences, and make decisions based on the data they gather from their environment. AI could also play a role in spacecraft design, helping engineers optimize the structure, materials, and systems to ensure that they can withstand the challenges of long-duration space travel. By simulating different conditions and scenarios, AI can help identify potential weaknesses and suggest improvements to the spacecraft's design, making it more resilient and capable of withstanding the harsh conditions of interstellar space. As we continue to explore space, one of the most exciting prospects is the potential for space colonization. While space exploration has largely focused on robotic missions and human missions to the Moon and Mars, the ultimate goal is to establish permanent colonies on other planets. The surge of 7 comets in 2025 and the passage of interstellar objects like 3I Atlas only reinforce the need for humanity to become a multiplanetary species. The development of space habitats, sustainable ecosystems, and long-term human survival in space will be essential for the future of humanity. Establishing colonies on other planets presents enormous challenges. First and foremost, we must develop technologies that can support human life in space for extended periods. Space habitats must provide a sustainable environment, including food, water, air, and protection from cosmic radiation. The technology to recycle resources, such as air and water, and to grow food in space will be essential for long-term space colonization.
Second, we must find ways to protect astronauts from the harsh conditions of space. Cosmic radiation, extreme temperatures, and the vacuum of space present significant risks to human health. Developing advanced shielding technologies and life support systems will be key to ensuring that humans can survive and thrive in space for extended periods. Mars is often seen as the first candidate for space colonization due to its proximity to Earth and its relatively hospitable environment compared to other planets in the solar system. While Mars is cold and lacks a breathable atmosphere, it has many of the essential ingredients needed for human survival, such as water in the form of ice and a day-night cycle similar to Earth's. Human missions to Mars are already being planned, with SpaceX's Starship and NASA's Artemis program setting the stage for human exploration of the Red Planet.
The goal is to establish a sustainable human presence on Mars, which could serve as a stepping stone for future missions to other planets and interstellar exploration. The surge of 7 comets in 2025, coupled with the passage of interstellar objects like 3I Atlas, has fundamentally altered humanity's perspective on the cosmos. Space exploration is no longer just about exploring distant planets or searching for extraterrestrial life. It has become about securing the future of humanity. The idea of humanity becoming a galactic species is no longer a far-off dream, but a growing reality. As we look to the future, the next logical step is for humanity to become a multi-planetary species capable of living and thriving in space. Historically, human civilization has been grounded in Earth. Our survival, our culture, and our very identity have been tied to this planet. But the discoveries made over the past few decades, whether through the study of comets, interstellar objects, or the search for exoplanets, have begun to change that. The idea of humanity branching out beyond Earth has been around for centuries, but today, space exploration is increasingly seen as a necessity, not just an aspiration. The recognition that Earth is vulnerable to cosmic threats such as asteroid impacts, supervolcanoes, and even human-induced disasters has motivated scientists and space agencies to take steps toward off-world colonization. Space exploration, rather than being just an exciting venture, is viewed as crucial to ensuring the long-term survival of humanity. By establishing colonies on other planets, moons, or even in space itself, we can safeguard the future of our species against unforeseen cosmic or environmental threats. The challenge now is not only how we explore other planets, but how we make space a viable environment for human life. The Moon has long been considered the first stepping stone for humanity's journey beyond Earth. NASA's Artemis program and private ventures like SpaceX's Starship are laying the groundwork for returning humans to the Moon and establishing a sustainable presence there. The Moon's proximity to Earth makes it an ideal location for testing technologies that will be needed for longer missions to Mars and beyond.
Mars, however, is the ultimate goal for space colonization. While its conditions are inhospitable to human life, with its thin atmosphere and harsh climate, Mars offers a potential home for humanity. It has water in the form of ice, a day-night cycle similar to Earth's, and an atmosphere that, while not breathable, can be utilized for producing oxygen and fuel. NASA, SpaceX, and other space agencies are already working towards sending humans to Mars in the coming decades, with the aim of establishing the first permanent human colony there. Mars will not be the final frontier, however. As technologies advance, space exploration will expand into the outer solar system, with missions to moons like Europa, Titan, and Enceladus. These moons are considered some of the most promising locations for finding life beyond Earth. The long-term vision, however, is interstellar travel, reaching other star systems and exploring planets orbiting distant stars. This vision, while still decades or even centuries away, is becoming more feasible with each advancement in propulsion, energy systems, and life support technologies. As humanity ventures into space, we are not only tackling technical and scientific challenges, but also facing ethical and philosophical dilemmas. Colonizing other planets raises important questions about how we interact with those environments. Should we terraform planets like Mars to make them more Earth-like, or should we find ways to live within their natural conditions? What rights do we have over these new worlds, and how do we ensure that our actions do not repeat the mistakes of colonization on Earth? Additionally, space exploration invites reflection on the nature of human existence. As we begin to colonize space, we must ask ourselves what it means to be human. What will our identity be in the vast expanse of the universe? How will we adapt and grow as a species, both physically and culturally, as we encounter new environments and challenges beyond Earth? The surge of 7 comets in 2025 and the passage of 3I Atlas are not just significant events in the history of space exploration. They are reminders of the vastness and mystery of the universe. These events have captured the attention of scientists, philosophers, and the public alike, inspiring awe and curiosity about the cosmos and our place within it. As we continue to explore space and uncover the secrets of the universe, we are not only advancing our scientific knowledge, but also reshaping our understanding of existence itself. One of the key lessons that the surge of comets and the passage of 3I Atlas teaches us is the inherent uncertainty of the universe. Despite our best efforts to understand and predict the behavior of celestial bodies, space remains a realm of the unknown. Objects like 3I Atlas, which arrived unexpectedly and traveled from another star system, remind us that the universe is vast, dynamic, and unpredictable. Even with our advanced technologies and scientific models, we cannot foresee every cosmic event. This uncertainty is both humbling and inspiring. It pushes us to keep exploring, questioning, and learning.
The unpredictability of space also highlights the fragility of life on Earth. As we confront the challenges of cosmic threats, from asteroid impacts to solar radiation, we are reminded of the vulnerability of our planet. The surge of comets in 2025, while fascinating, also serves as a wake-up call that we must not take the stability of our environment for granted. By studying these events and preparing for future threats, we can safeguard the future of humanity and continue our quest to understand the cosmos. As we look to the future, the question remains, what is humanity's role in the vast, interconnected universe? Are we merely a speck in the cosmic drama, or do we have the potential to play a significant part in shaping the future of space exploration? The discoveries of the past few years, such as the surge of comets, the passage of interstellar objects, and the growing interest in space colonization, suggest that humanity's journey into the cosmos is just beginning. The dream of becoming a multiplanetary species is within reach, and the quest to explore other stars is no longer a distant fantasy, but a growing reality. As we continue to study the cosmos, we must also reflect on our responsibilities as explorers. Just as we have the potential to colonize other planets and moons, we also have the responsibility to protect and preserve those environments. The lessons of Earth's history, its environmental degradation, its conflicts, and its struggles should inform our approach to space exploration. If we are to thrive as a species beyond Earth, we must do so in a way that respects the cosmic environments we encounter. The surge of 7 comets and the passage of 3I Atlas represent a turning point in human space exploration. These events have sparked new interest in the study of comets, interstellar objects, and the future of humanity in space. As we continue to develop new technologies, improve our understanding of the universe, and expand our presence in space, we are creating a legacy for future generations. A legacy that will be defined by exploration, discovery, and the pursuit of knowledge. These cosmic events have shown us that we are not alone in the universe, and that the universe itself is far more dynamic and interconnected than we once believed. The study of comets, asteroids, and interstellar objects has opened new frontiers in space exploration, offering glimpses into the origins of life, the nature of the galaxy, and the potential for life beyond Earth. As we continue to explore space, we are not just learning about the cosmos, we are learning about ourselves and our place in the grand scheme of the universe.